time out of your busy schedule to participate in this webinar and to learn about the modifications that are forthcoming in the tall buildings code. The revision is now in wide circulation, and that is why we are able to discuss publicly. It's really encouraging to note that this topic has generated so much of interest. As per the information I received from the Secretariat, we have about 1,200 participants who have registered for this webinar. Though our Zoom license can only accommodate 500 participants, so we are likely to have more participants than what we can accommodate in this Zoom platform. Hence, we are allowing live streaming of this webinar in YouTube. And those who are not able to get in after 500 participants are requested to join YouTube Live. The link is already sent to all the participants. Today, for this panel discussion, we have a very elite panel of experts who are invited to share their views. And I take this opportunity to warmly welcome all the expert panelists and thank them profusely for accepting our invitation, for sparing their valuable time. Before we start the panel discussion and talk about what's there new in this revised code that is coming up, I would like to take a few minutes of yours and to look back at the history of development of this code, and also talk a little bit about how the structural design practice has changed worldwide over the years as far as the tall buildings are concerned. So Vikas, can you put the next slide, please? So this is an interesting graph which shows how the limits of maximum height of building have evolved over the years worldwide. The graph, I say, is interesting because it can, one can also see how the maximum building height has evolved in India over the years and can compare it with the world record figures. While the maximum building height may not be the only yardstick to measure the progress and development in our codes, but nevertheless, it is certainly one of the yardstick, and it reflects that we have, this graph definitely reflects that we have a lot of catching up to do in development of our codes and our practices. If we want to narrow this gap, and considering the pace of development in India, I'm sure in times to come, this gap will be narrowed significantly. And we all need to work towards that. If you really closely see this graph, it shows that there is a gap of nearly 80 years in reaching the maximum height. For example, at present, we have reached a maximum height of about 300 meters, while the height of 380 meters was reached way back in 1931 in New York with the Empire State Building, which was constructed then. In India, really, the this record taking started from 60s, early 1959, when we had the first building 15-storied in Chennai. And then in 70s, it rose to 54 meter to 80 meter. And then we have this, when we had this 25-storied Usha Kiran building in Mumbai. And then today, we are at around 280 meters. And as per my records, one building which is more than 300 meters is still to be sort of put to use, though it is completed. I think the finishing and all are ready. And also I understand that there is some building in the pipeline which is going to cross 500 meters, but that is in the proposal stage, if my information is correct. So this is the state of affairs as far as the tall building is concerned. With this brief background of information, let me come back to today's agenda. And the objective of this webinar is really twofold. Firstly, it is to apprise the participants who are mostly code users with what modifications that are proposed in the code, which is currently in wide circulation. Aim is to go into the details of the proposed changes, collate all the comments and observations made by the panelists during this panel discussion today, and we are going to forward all the observations finally to the BIS code committee for their consideration. Second objective is also to discuss broadly the expectations of the practicing engineers and code users for future growth of this code. I mean, the buildings are going to be more and more complex in shape. We know that, I mean, we have very little control on the shape of the buildings that are coming up, particularly in the tall building sector. We are seeing many twisted buildings also in the horizon, and we have no way to stop this. The only thing is the structural engineers, we can never be, we can no longer be a kind of a roadblock or a stumbling block in the progress, and keep our codes restricted, thinking of only what capacity we have. I think it's a question of chicken first or egg first. And this is a debate which I think in the panel discussion we will also discuss. What is the future of the code? The structure of the proceedings today will be as follows, that as given in this slide. Uh, so before taking it forward, I think further, let me move forward and request our President, Mr. Manoj Mittal, to give his welcome address to this occasion on this virtual gathering. Mr. Manoj Mittal is pretty well known to all of us. He is the president of IS Shakti, and also he is an accomplished civil and structural engineering consultant, having more than 35 years of rich professional experience. I would request Vikas to put his CV in the chat box for participants to view in detail. But I would request Manoj to kindly come in and take the virtual podium to give the welcome address.
Thank you, Alok. Good afternoon and welcome to the webinar on the revised draft code IS 16700. As Alok said, it is an important standard for tall buildings, and I'm sure the online seminar, this seminar, will be useful in understanding the code and issues which needs attention of the BIS before publishing it. And it is also heartening to note that we have around 12,000 participants registered for this event, and I hope significant number will attend this event. Our guest speakers and panelists, Professor Tandon, Dr. Yoginder Singh, Mr. Abhay Gupta, Abhay Ghate, Mr. Girish Dravid, Mr. Vipul Ahuja, Ms. Sangeeta Vij, and Alok Bhaumik are very experienced and accomplished structural engineering experts. And I welcome you all to this event. And as you know, this IS Shakti is a national apex body of the structural engineers in India. And it is highly active in conducting capacity building and knowledge sharing events. It is also very actively publishing quality technical journals and other professional guidelines. I would encourage you all to become the member of this association if you are not the member, and it will surely add value to your professional standing. IS Shakti National Awards for the year 2022 have already been announced, and you may also submit your nominations in the prescribed format. Even if you are not the member of the association, you can still participate in its activities. Just keep track of announcements and visit the website regularly. I once again welcome you all and hope you will enjoy the event. Thank you.
Okay, thank you, Mr. President, for your nice welcome address. So now let us start our proceedings. We have with us Professor Yogendra Singh of IIT Roorkee as the keynote speaker for today's panel discussion. We also have, as Mr. Manoj mentioned, 5 expert panelists. Professor Mahesh Tandon, Managing Director, Tandon Consultants Private Limited. Mr. Vipul Ahuja, CEO and Director of Ahuja Consultants Private Limited. Ms. Sangeeta Vij, Managing Partner of SD Engineering Consultants. Mr. Abhay Ghate, Chairman, Optimal Consultancy Services Private Limited. And Mr. Girish Dravid, who is the Director of Starling Engineering Consultancy Services. All our panelists and keynote speakers are pretty well known, and they hardly require any introduction. But still, for the sake of formality, we will do that. I will first invite our keynote speaker, Professor Yogendra Singh Ji, first to give a broad overview of the current tall building code and the proposed changes. I request Professor Singh to conclude in about 15 minutes. And thereafter, I will be inviting all the 5 esteemed panelists to give their views on specific clauses of the code, one by one. That is the structure of today's webinar. The clauses they are going to cover, as I think, because if you can show the next slide. So basically, all the panelists after the keynote speaker, Professor Yogendra Singh speaks, will be covering specific clauses of the code. Namely, Professor Tandon will be covering clause number 5 and 6. Mr. Vipul Ahuja will be covering clause number 7 and 8. Mr. Girish Dravid will be covering clause number 9 and 10. And Ms. Sangeeta Vij will cover clause 11 and Annex A. And our last speaker is Mr. Abhay Ghate, who is actually joining us from US. And he will be covering Annex B, which is on the, so that is the structure of the presentation that we are going to have today. So may I now request our keynote speaker of the day, that is Professor Yogendra Singh Ji, to present a broad overview of the code, that is IS 16700, and the revisions of the proposed that are proposed. Professor Yogendra, I have the privilege to introduce him. So Professor Yogendra Singh is a professor from IIT Roorkee, railway bridge chair and former head earthquake engineering at IIT Roorkee. He has a research interest in performance-based design of buildings and bridges, seismic vulnerability and risk evaluation, nonlinear modeling and analysis, and seismic evaluation and retrofitting of structures. He has over 28 years of research and teaching experience, guided 14 PhDs and 82 MTech dissertations, published 81 research articles in refereed journals, and presented more than 100 papers in national and international conferences. I think Professor Yogendra Singh has an immense contribution even in IAS Structi in various refresher courses and webinars. He has been contributing significantly in the capacity development of engineers in the country. Over to you, Professor Yogendra Singh, for your keynote address.
Thank you very much, Bhaumik sir. I hope I'm audible. I will share my screen.
Yes, sir, you are audible.
Let me close this. Okay. So thank you very much. I'm thankful to IAS Structi for organizing this event and giving me the chance to speak about IS 16700 as well as the changes which are coming up. So I'm planning to give an overview of what changes are proposed in the code, but I will not go into the detail because that will be dealt with the other panelists. I will focus on two aspects, one regarding the design period and another one regarding the limit on interstory drift. So those two aspects I will go in detail. So first issue is that why do we need a code, especially for tall buildings? Can't our other code, that is IS 1893 and 13920, can take care of these tall buildings as well? So the forward and the scope of IS 16700 specifies that structural systems for tall buildings may be different than those which are covered by IS 1893. For example, in case of tall buildings, we have to go for frame tube or tube in tube construction. So what parameters and design methods should be used for those type of systems, that is perhaps not covered by our other code, which is applicable to general structures. So that's why we need a separate code. Then wind and seismic effects, those are on tall buildings, those are specifically focused in this code. Then methods of structural analysis, which we require for tall buildings, as higher mode effects are important. So the method of structural analysis which we are using should take care of those higher modes. Structural design aspects of tall buildings are also covered. And then most importantly, the procedure for approval of non-conforming buildings, because there will be always some buildings which will fulfill the requirements which are not covered by the code. And in such cases, how the building should be designed, that procedure will also be dealt with detail with one of the panelists here. So also what this code does not cover, that is also specified in the scope. So this standard is not applicable for tall buildings located in near field seismogenic faults. So what is near field? Which is within 10 kilometers from the known faults. And there is a query always that how to know the faults. How do we know where the faults are existing in our country? So I can inform here that Geological Survey of India, GSI, has published a seismotectonic atlas of the country, and that atlas gives plots or maps of all the known faults so far. So from there we will come to know what location these faults are and whether our building or any other structure is in the near field or close to those faults, known faults within 10 kilometers. So the code says that in that case it is not applicable. But what exactly is to be done when it is within those 10 kilometers? It is not very clear from the code. One thing which is to be done is that in near field we have to go for site specific hazard assessment. And as far as I think that rest of the design considerations will remain same. Only thing we have to keep in mind is that when the building is within 10 kilometers, we have to go for site specific hazard assessment. And if the building is sitting right over the fault, then there is a possibility of surface expression of that fault. And in that case, the building will be subjected to very large support movement if it is right on the fault. Then this standard is also not to be used for buildings of height less than 50 meters. Those are covered by our other code. But if somebody desires, these can be used for that those buildings also. And the code says that in that case, these will add the value. We will see what those different aspects this code covers, which can add value to ordinary less than 50 meter high buildings as well. So the changes which have occurred, which are proposed in this code, these are first of all the structural. There is a change in the structural systems which were given in table 1 and 2, and the one change is that the buildings with shear walls only at the core, because in case of tall buildings we have a large service core, and there is a possibility of enclosing that service core with shear walls. So we are providing a shear wall core near the center of the building. So that type of configuration is no more allowed. That is the one change. I will discuss what is the basis of that decision and how it is going to affect our design. Then a new expression has been given for calculation of fundamental period. We know fundamental period, which is having a capping over the period which we are getting from the analysis, and that governs the minimum base shear which we are using in our design. So this has a very crucial impact on earthquake forces which we are calculating. So there is a change in that formula. We will discuss that. Then the load combinations have been changed, which consider period effect. This will be considered by other panelists. And an expression for interstory drift. The basis of limit on interstory drift has been changed. We will discuss that. And the procedure for approval for non-conforming buildings, there is some change in Annexure A. That will also be discussed during this panel discussion. So first change, which is of interest to us, is whether or those buildings in which structural walls at core, and this alone word I have added. So it is not that the structural walls or the shear walls cannot be provided at the core, but those shear walls at the core alone are not enough. We have to provide shear walls well distributed among the plan or within the plan of the building. Reason for that is that when we are providing shear walls in the core, the lateral stiffness increases, but the torsional stiffness does not increase in the same proportion. And as a result, we will get a torsionally flexible building. And the first mode, the fundamental mode, may come out in torsion. So that can be taken care of if we are providing other shear walls preferably along the perimeter. And if it is not possible to provide along the perimeter, then it should be distributed within the plan of the building, so that not only the lateral stiffness is increased, the torsional stiffness is also enhanced. And torsional stiffness is proportional to the square of the distance of the shear wall from the center. So as far away from the center we are providing the shear walls, higher the torsional resistance will be, and we will be able to satisfy that the first two modes are not torsional modes. But there is an issue when we go ahead with this condition, then the code also accepts the structural systems like frame tube systems. In frame tube systems, it is not possible to provide shear walls because we are having closely spaced stirrups. And especially in case of tube in tube system, where the inner tube is made of shear wall and the outer tube is made of frame. So there will be some conflict in satisfying this condition, where the shear walls are not allowed at the core alone, and those should be distributed. And we can see here these systems are accepted by the code, but how that condition will be satisfied, that is not very clear. So that we can discuss. Then there is change in the approximate fundamental period, and this is these two are the expressions. The first one is for moment resisting frames, and the second one is for all other concrete systems. And we know in case of zone 4 and 5, the moment frames alone are not provided, are not accepted. And we know that in case of tall buildings, moment frame is not a very efficient system because it is very flexible. It becomes difficult to satisfy the interstory drift. Then we are not going for this. So in most of the practical cases, it will be the second formula which will be applicable. The source of this formula is ASC 722. So in ASC 722, different types of structural systems are identified, and the two systems which have been taken here, these are the concrete moment resisting frames and all other structural systems. So the same expression multiplied by a coefficient Cu, which depends on the seismicity, and for PGA greater than 0.3 and 0.4 G, these values are 1.4. So in proposed IS 16700, this value of 1.4 has been chosen from here, and accordingly these two expressions have been given. The commentary of ASC 7 also provides the basis how these 1.4 to 1.7 these are to be chosen. That depends upon the seismicity of the area, because in less seismic area, the sizes of the beams and columns are expected to be smaller. The building is expected to be more flexible, and as a result, the period will be longer. And this multiplication factor, larger multiplication factor, is allowed. Now, if we look at a comparison of this new formula with the old formula or those which are existing in IS 1893. So the top one is the formula for bare frame as given in the revised 16700. The middle two here, the yellow one is as per IS 16700 for other structures, this yellow one, and the red one, the lowest one, is for infilled frame as per IS 1893. So we can see that there is drastic change in case of the moment frame buildings, whereas the other buildings, there is a difference there also, but the difference is not so large. And if we see what impact it will have on the calculated base shear. So here I have compared the calculated base shear for different formula, which I have shown here, period formula, along with the minimum base shear as recommended by 16700. So we can see that in case of bare frame buildings, because this tall building code starts from 50 meters. So beyond 50 meter, it is the minimum base shear which is governing. So this period formula is not coming into picture at all. And the moment frames are allowed in zone 2 and 3 for heights above 50 meter also. But if we go in zone 4 and 5, then the moment frames are not allowed. We have either frames with shear or other types of structural systems. So for other systems, we can see beyond about 120 or 110 meters, it is the minimum base shear which is governing. Same is the situation in zone 5. So beyond this height, it will be the minimum base shear. In other words, with these formulae, the design base shear has been reduced significantly. And as a result, the bare frame buildings will be designed for much lesser earthquake force in comparison with IS 1893. Then there is an issue that what will happen just at the 50 meters, because less than 50 meter it is IS 1893 is applicable, and beyond 50 meter it will be IS 16700. So we have to look for the similar changes in IS 1893 also, so that the design from the two codes is consistent. And in this regard, if we are using 16700 for buildings less than 50 meter, as the code says, actually it is not adding value, rather it is reducing the design force for buildings less than 50 meters. The other important point which I wanted to discuss was in this proposed change, that is the formula for limit on interstory drift. So in this proposed revision, the interstory drift is related with the P delta effect. So the expression given in the code is like this. We can do a little simplification, and if I rearrange these terms, actually the origin is from AC7 again. So in AC7 there are two limits given on interstory drift. One which is coming from the stability point of view, from the P delta effect, and the another one coming from the damage point of view. So this stability limit, if I rearrange a little bit, it becomes like this: delta I by hi. So delta is the interstory drift, hi is the story height. So it becomes interstory drift ratio, which is given as 0.4% in IS 1893. So that is given something like this, where Vi is the story shear and Pi is the vertical load. So ratio of Vi and Pi we can take as the minimum design base shear coefficient, and that minimum design base shear coefficient is given for different zones in the code. If I substitute those values, this expression gives the interstory drift limits like this. It is different in different zones, and it is 0.14 into R, 0.14% into R in zone 2, and in zone 5 it is 0.48% into R. So one thing which I can see here, that this R appears to be by mistake. This R should not be there. So it should be comparable with what we have in IS 1893, that is 0.4%. So that becomes 0.004. So this R perhaps is coming by mistake. And the reason for that is that the definition of delta I in our code and the definition of this delta XE or delta E in AC7 is different. Our code talks about this delta design corresponding to the design base shear. So we can see here this design base shear for which we are designing our building is the reduced base shear, and the corresponding drift we are taking as the design drift. Whereas in case of AC7, the design drift is the inelastic drift here, and the ratio between the inelastic drift and the design drift is R. So it is my understanding, looking at the code, that the code has confused between the two drifts. One is the inelastic and another is the design. In our code, we are dealing with this design drift which comes for the reduced force, whereas in AC7 it is the inelastic drift, and using equal displacement principle, this inelastic drift comes R times design drift, and that's why it is perhaps required to remove this R from here. So in case of AC7, another drift limit is provided, and that drift limit is coming from the control of the damage. And for all other structures, depending on the importance, it varies. The inelastic drift varies from 2% to 1%. So if we take the limit of IS 1893, 0.4%, and multiply it by R, then that becomes equivalent to 2%. Whereas in case of AC7, it is also equal to 1% in case of important structures. And this will depend upon also what type of partitions are provided, how much damage is acceptable in the structural and non-structural components. So something similar we have also to provide in our code. And to conclude, 3 changes perhaps we can recommend in this revised draft. One is the freedom to select the structural system. So currently in our code, the structural system is binding. Beyond a particular height, we cannot use a particular system. Although that's not there is no scientific basis for that. As we know, Taipei 101 is a mega frame building. So they have used one of the world's tallest building has been using the concept of the frame. So there should not be a limit. There should be rather suggestive range, that in this range, this type of structural system is more economical or more viable. That type of recommendation can be there in the code. Then, as I explained, that from the drift formula, there appears that this R has come inadvertently and this R may be removed. And we need another drift control limit, not only for the stability, which is currently given in the code, and that limit should be based on the accepted level of damage. Thank you.
Thank you very much, Professor Yogendra Singh, for such a critical appraisal of some of the provisions of the draft code, and very enlightening. And I think we will have, I'm sure, a lot of discussions after the end of all the panelists, giving their views first. So now I would like to invite the first panelist, Professor Mahesh Tandonji, to talk about the provisions of clause number 5 and 6 of the code and the revision. Professor Mahesh Tandonji hardly requires any introduction to the fraternity. He's very well known, past president of IAS Trucktee, managing director of TCPL, and guest professor IIT Gandhinagar. He's an international expert in the field of structural engineering. He is a fellow of Indian National Academy of Engineering. He's also an international professional engineer, members of various code committees, BIS, IRC, and also visiting professor at IIT Kanpur, IIT Roorkee, and Gandhinagar. He has accreditation of international professional engineers from Institution of Engineers, India. So I now request Professor Mahesh Tandonji to kindly share his views.
Thank you, Alok. Is my screen visible?
Yes, sir. Only thing is you can make it presentation mode.
Okay. Thank you. Thank you very much, Alok, and good afternoon to all the participants and my fellow panelists. So I will limit myself to these two chapters, although I would have very much liked to discuss some other things also, but I'm sure that we'll get a chance to discuss those at the end after all the presentations are made. So the first thing is, without too much repetition, this is part located at code, structural wall. This part has been removed from the code. This is the old code which I'm showing you, and I will show you the new code. So this vertical column has been eliminated. The other thing, as you can see here, that thing has gone for wall. The other thing I would like to say is that they should reconsider the nomenclature which they have put here. If whatever nomenclature they want to use, my suggestion would be to use a nomenclature which is generally known and published everywhere. And in any case, whatever they use should be, there should be a figure which describes what we mean by all these nomenclatures. This is one example which I wanted to show you. What is of interest for example, for our case, what is applicable in this code are these first few systems. And I think that these should be elaborated and they should be called by the name, not only diagram, but name also should be similar. You cannot have some other name. And if you want to read about it, the Skidmore, Owings, and Merrill, who are the pioneers in tall buildings and where Fazlur Khan worked, they have come up with a new addition by this gentleman, Mark Sarkisian, and he's from Fillmore, Owings and Merrill, and this book has been combined. It has been jointly authored by the two. You see this building, for example, you have the very closely spaced columns on the cladding or on the surface of the structure. And if you see it in plan, there is the core, which also has a function. And you've got very closely spaced frame columns, as you can see here. And of course, every floor you have a connection. So it's a different type of, it is not merely some frame building. It's a different type of things. And this is what we need to use the wordings which are commonly understood, and also give a diagram of what they look like. Now, I think Professor Yogendra Singh mentioned about this drift under natural conditions. No, I think he mentioned that, yeah. So the change is that it used to be a return period of 50 years when you are calculating natural drift, and now they have made it 20 years. I have looked at the international codes of practice. I think it seems to be more or less okay, whatever change that they have made. This I wanted to show you. Thornton Thomasetti, he is the designer of the Burj Khalifa building in Dubai. And not only that, he has worked all over the world. And in one of his presentations, I have taken out one slide which tells you what are the lateral deflection limits. Like, for example, in USA or in Dubai, it is h by 400 to h by 500. But they have given the return period of the wind, which is not the same as whatever is just given in IS 875. So this is something, first you have to convert that to the required return period and then work on these. So in various places where you have tall buildings, they have come up with this chart. And the other thing is, whether you are considering P delta effects or not, you have to check both with P delta effects and without P delta effects. You cannot just say you take P delta effects into account. That is what our new code says, that you have to take account of P delta effects. But it doesn't say that you have to check for both the conditions, because the return period for both of them have to be different. And the allowable limits also are different. This is, there used to be a clause on vertical acceleration of floors, which has been deleted. And I think this is the right thing to have done. The vertical acceleration of the floor, as far as seismic effects are concerned, it's really not to be taken into account. But if there are other vibratory forces, it's another issue. But we are talking about only tall buildings and the effect of wind and earthquake. The other thing that have changed is the lateral acceleration limits for residential buildings. The peak combined acceleration was 0.15 meter per second square in the old code, which has been made into 0.18 meter per second square in the new code, which means that it has become a little more liberal to the extent of the limit. A new expression for the fundamental natural period, which Professor Yogendra Singh explained. The problem with this is that it never says what kind of walls that you have to take into account. These days, as you know, there is a lot of aluminum formwork which is going on, and the partition walls are also made in concrete. Now the question is that, do you have to take those into account when you are finding out the natural period, not by this formula, But when you are doing the analysis, according to me, for these 100 and 125 millimeter thick walls, you should neglect these when you are trying to find the natural period of vibration. This is just an example to show you one of the tall buildings which we are designing, that there are so many of these small, thin walls which have to be provided. You don't have to take them into account when you are trying to find out, analyze by analysis the period of vibration. I have already talked about the P delta effects. It's in actually outside my terms of reference, but in 7.2 and 7.3.9, they also said to include P delta effects. But P delta effects, when you consider and when you don't consider, these two have to be treated separately, and the return periods and the limits have to be defined well, properly. The last slide that I want to show you is that on wind effects, they have said something like the minimum design wind base shear shall be at least 70% of that derived based on IS 875 part 3. They are talking about that if you do a wind tunnel test, then what governs? Is it the IS 875 or the wind tunnel? The way this statement is made, it seems that if you do a wind tunnel test, you can just take 70% of the 70% of what is given in IS 875 part 3. I don't think this is what is their intention, but these wordings have to be carefully done. So this should be specifically mentioned that this clause 622 applies only when you have buildings which are mentioned in 6.2.1, which means complexities in plan, site complexities, and so on, and natural period greater than 5 seconds. When any one of these comes into the picture, only in those conditions he is talking about that you can neglect what is in IS 875 and use up 70% of that if your wind tunnel tests are giving you lower results. Not in every condition where you do wind tunnel tests. So the wordings has to be improved. That is what my feeling is. Okay. Thank you very much.
Thank you, Professor Tandon. Very well put all the points. I think we will have a greater discussion after all the panelists speaks. I would now invite Mr. Vipul Ahuja to speak on the clauses 7 and 8. Mr. Vipul Ahuja is a licensed structural engineer of California. He is a CEO of Ahuja Consultants Private Limited and a very key governing council member of Indian Association of Structural Engineers. He is a life fellow of Indian Institution of Engineers and a life member of ISET. He has a vast experience of more than 40 years in the field of structural and earthquake engineering and has design experience using steel, concrete, reinforced masonry, fiberglass, and timber for various building material as a building material. He has experience in engineering of performance-based design, base isolation, and damper applications in high-rise buildings, both steel, concrete, as well as composite. He has also designed a base isolated commercial building and several studies, including double isolation system, etc. So over to you, Mr. Ahuja, for your presentation. You have 10 minutes.
Thank you for your kind words, Alok. Is my screen visible and am I on?
Yes.
I'm visible. Thank you.
Yes to both.
Okay, so let's jump right into the clauses. And basically what my intent over here is, not only am I showing some, what parts I may propose to change, but also just illustrating for the benefit of some viewers who may not be familiar with some of the complexities, some minor things here and there as well. So for 7.2D and 7.3.10, I think the P delta part, which has been touched upon by Professor Yogendra Singh and also a little bit by Professor Kannan. So there's this new flexibility equation of theta is equal to P delta over VHI R, which is less than 0.2. And Professor Singh has shed some light that maybe R is superfluous over there. I'm not very sure, but let's get into that. And then, of course, there's this in the previous amendment, there was this equation of 1.2 dead load. That's for the initial analysis before the final analysis. So the building is deflected, given a pre-deflection, so to say, prior to the final analysis of that much. So just to recap, P delta effect is a nonlinear geometric nonlinearity, and you have a horizontal force applied and also along with the vertical force onto the building. And then in the next, this is the first iteration. And then because of that vertical, the D1 eccentricity, it jumps up to D2 and so on. So and finally it stabilizes. So that's why the iteration comes in. And simultaneously, there's this curve which has been taken from ASC 7. So the stiffness of the system also changes. And you can see the slope over here, including the P delta is over here, and excluding this is horizontal curve. So it has a big impact on the stiffness matrix of the system. So here, if I've got both the IS 16700 and as well as the ASC 7 over here on the right side, which is showing both these equations of theta. So here they are showing one thing over here, which is that if this theta value is less than 0.1, then no P delta is required. And I think for the consulting community, that will be for a stiffer building, that will be a very big respite if we have that kind of a clause in our code. Okay. Whereas what Professor Singh was saying, they have the CD over here, which is somewhat close to half of R value. So something like similar to what we are looking at is already over there. So maybe this requires a little discussion, and then we'll all be on the same page. But if there is a problem, then indeed we should take care of it. Then table 5, which is basically this one over here for the cracked sections. This should include cracked section properties for out of plane bending of shear walls as well. The raft section is missing, and the shear cracking, it should be there in all elements. Coupling beam cracking is missing. Diaphragm in plane cracking is missing, which we are seeing over here in the ASC 7 code. The shear is, this last column over here, and this column is entirely missing in our from our code. So, and then of course, for columns and all, we have different conditions. We have for actually highly axially loaded or flexibly. There's an equation here also, for columns for highly loaded and less loaded, and then coupling beams also there are different scenarios. So we need to really compare a little bit, and it's not such a simple result that we'll get out of this. So modeling of then we'll talk about modeling of soil is mandatory if there is an extended basement together like a backstay model. Okay. So our code is talking about both in 7.3.8 and in 9.7 the modeling of soil. Okay. Now that has to do with the soil structure interaction system, or condition. So if you have a very stiff building again or very stiff soil condition, then the hinges happen to be at near the base of the shear walls. And this can get a big relief if you put in soil structure interaction. And if you have, a very flexible condition in the soil, and you have, and your all the force goes away from the wall, and the wall simply rocks, and then you have all the failures happening in the beams and columns, okay, like shown over here. So we refer to FEMA 2091 for this condition. So these are special conditions. So this is what you see that you, for stiff building, you get this kind of for wall, you get this kind of displacement. Then in addition, for soil structure interaction, you get this additional delta R. So here's a rule of thumb which is also given in 2091 FEMA, which shows there's a small equation that you can easily check that when soil structure interaction is important. So H is the height of the building, and Vs is a shear velocity at that site, and T is the time period. So assuming, let's say for this building, so they plug in the numbers and they find that this equation is giving a value of 0.11. So therefore, they conclude that the soil structure interaction initial effects are likely to be significant. Okay. So then we jump into another, this 7.3.11, where it says you ignore the stiffness of the gravity elements. Okay. So here we want to say that you want to add the deformation compatibility. Yes, we ignore it, but then we also have an additional analysis, which will, for example, you have a flat slab, and I pin both the top and bottom of all the columns for the first run where I ignore the stiffness of the gravity elements. But in the second analysis, I put it in, I multiplied by R as it's given in 1893, and then we do the deformation compatibility, and then we pick up the moments and axial loads from that second model. So it's a double analysis that we need to do when we are dealing with the gravity elements. We need to do it both ways. It's not that we only ignore it. So yes, I'm sure that the committee has already taken into account, but I think a reference over here is warranted to the 1893 for deformation compatibility. Then construction sequence is required for buildings taller than 150 meters. So here over here the effect of construction sequence shall be considered in buildings taller than 150 meters. So the construction sequence is actually required for a lot of conditions, not only 150 meters. Like for example, you have gravity columns and you have transfer girders on the ground floor. So there also, or on any floor as far as that goes, you need construction sequence analysis for that also. Because that's how the real state of stress is going to be captured. Okay. Then we get into 7.4.2 where there's some non-structural elements also addressed in this chapter 7, and even though it's not my charter, I just thought I'd mention it. That here cross-referencing section 10 is would be very useful also. And then like in 16,700, we have this equation which is also from the ASCE, but now in the new ASCE 22 which has come out, there's an entirely new equation which is looks very different from the older one, because this takes into account the acceleration at that floor where the equipment is placed. So this is a much more gives much more relevant results and reasonable results as compared to this old equation which was there. Then we talk about modeling of unconfined staircase, which is not a new feature this time, but at the same time, I just thought it would be good to because of what I do some proof checking and all, and I find that the unconfined staircase, which means that staircases that don't have shear walls on all four sides are there, and they can really create havoc in terms of causing captive columns and providing the stiffnesses like braces, like a brace frame, which is unaccounted for in the analysis. So this is a very important feature, and it could mean that we even design the base slab with stirrups, just like a in-plane, a beam of sorts, or a shear wall, or a line 45-degree shear wall, or whatever 30-degree shear wall. So that, and then it has tension and compression parts also. Tension and compression are on opposite faces. Steel is there. Then we go to 8.1.3.3, which is towers connected by a common podium. So we say that basement expansion joints are not continuing from floors into retaining walls is not effective in dividing the building structurally. which is a very common practice because people want to avoid leakages. So what they do is the practice is the joint is provided only in the floor, not in the walls. But this effectively increases the backstay effect. Okay, so it is wrong to idealize the building with only the relevant part of the basement and not with the entire basement unless you run the expansion joint through the wall, right to the foundation. So, so these are the things, and then transfer structure shall be not provided in. Okay, then there's another one, the K part. There's this paragraph C and then this paragraph K. So I say add overturning moments obtained from the respective towers. Okay, it just says overturning moments obtained from the response spectrum analysis. So we should add this term of respective tower, because if there are 5 towers in the basement, so I will look at the overturning moment in the of each of the tower respectively, and not club the whole thing together and then. So from the direct load path model. So from there we look at the overturning moments. Then the transfer structure shall not be provided at the first floor. So we say transfer structure shall not be provided for any vertical element which is part of the lateral load resisting system. So for a gravity system, we can understand that transfer should not happen over there, but also for any lateral load resisting system, it should not happen. That means you can't start the lateral system from the 5th floor also. Then vertical irregularities, weak story are not allowed. So to determine weak story, actually a non-linear analysis is required. We have also worked with CSI on this, and they've also said the same thing, that if it's determined to be weak, we should allow for redesign and elevated design forces. So then also we talk about 8.2 talks about ductility. Notwithstanding any of the clauses in the standard, the designer shall take all measures to ensure that this building has sufficient ductility capacity, acceptable energy dissipation mechanism, and desirable sequence of initiation of ductile behavior in members. Now, if I don't know, how in the world would a designer get this without doing a pushover analysis or a nonlinear time history analysis? So that means 8.2 is mandating virtually the designer to do a performance-based design or a nonlinear design at least. So then we have this discussion on 8.5.1, which is basically minimum thickness of walls should be 150 mm. Now here's an example. Here's a partition wall. We have been talking about monolithic partition, RCC partition wall, and what you see whole is a honeycombing basically over here. They're 90 millimeter thick, and if you look, this is a boundary element, and you can see how hollow this is. This is a 200 thick wall. So I really recommend that 240 millimeters should be a rock bottom minimum, or if not 300 millimeters for shear walls, to avoid this kind of a thing happening. And this is with my-band shuttering and everything. This kind of a thing is happening. So, this should be brought into the code somewhere on this clause. Then 8.5.10, they should be made clear that there is no splicing in the hinging zone allowed. Okay. So, I mean, anywhere, whether it is in the beams or whether it is in the wall. Now, in the shear walls, the potential hinge would form 1 story below the backstay level and 1 story above it. Or if the backstay diaphragm is not very stiff, then it will happen near the foundation, in the basement. So over there also, we should avoid having splices. Then redundancy requirements for this thing, 8.5.12. So I say you add, if the resulting system is not satisfactory, the structure shall be designed to resist 30% greater lateral forces. Now we just simply say over here that you should here's the redundancy clause over here. There is a requirement for each story to resist more than 35% base shear. Now that means the sum of all the base shear from above, if you take or shears and we come up with more than 35% for is being taken by that particular diaphragm, then the code says that for any wall which has a aspect ratio of more than height to length of more than 1, you take that out and that should not cause torsional irregularity, basically. But of course, I am unclear about this word story above, that you take out only the walls from the story above. So this is something to be debated, I think. I think it should be from right from the bottom to top, that if it's taken out, that you should not have a torsional irregularity. But nonetheless, it says if it's torsionally irregular, then you don't, then that's not allowed. But actually what ASC 7 says, and it has this redundancy clause over there, I've stated that clause also. It says that if you take it out, if that doesn't work, then you design it for a 30% higher lateral load. It doesn't give you a death warrant that you are allowed. Okay, you can design it for 30% higher load. And that is a redundancy clause, which is across the board. It is rho value should maybe 1.3 or maybe 1. So there are, with every clause that is used over there in ASC, 1.3 is required unless you have some exceptions. So this is like one of the exceptions which we should be aware of and not copy this blindly. And here is about same thing about weak stories. That it says there's this exception. The limit does not apply where the weak story is capable of resisting a total seismic force equal to omega, which is the overstrength strength factor times the design force prescribed in 12.8, which for our system, let's say it's 2.5, okay, for shear wall systems. So that means even if we have a weak story, but if you use this clause, if you design it for 2.5 times that force, the seismic force, then it's all right. So, I mean, otherwise, like I said, this is a death warrant for the building. You can't go ahead otherwise. So that's the other thing. So I think there's some discussion that we should really get into this, because there's some impossibilities that have been brought into the code. So how same thing over here, flat slab used in the deformation compatibility. And then 8.5.13, of course, now the longitudinal steel in shear walls is 0.4% already mentioned, and transverse steel stays at 0.25%. Then clause number E of this says the wall should not rock. Okay, so that means walls coming down to the structure, and on a transverse structure will rock, and that's what they're talking about. So and it says structural walls shall be fully embedded and anchored at the bases in the basement foundation, so the wall does not rock. So again, we bring in the point of the soil structure interaction, and we model the foundation over there with compression only springs and simulate the soil structure interaction over there. So then I just took a little brush at the non-structural components. So I think this part can be added over there. I heard a seminar of RWDI, and they are talking about imperceptible range of vibration affecting sensitive equipment like MRI and all, in hospitals. So those are on air springs, and these things are not covered in our standards. And I think that's something would be a good idea to put that in. Then in the structural design review panel, my opinion, at least, even though outside my charter, it says that the structural engineers who are reviewing on the panel should have at least 10 buildings of height of 150 meters and more. So we took a poll over here, and nobody in the NCR at least who got that. So I say that at least, and it is unfair actually, if suppose it's a 30-story building which is being debated, then at least, if not 100%, 80%, or some number that can be discussed, that the height of the height under this seismic zone. That means if it is zone 4, then at least 4 or 5 we should have done, with performance-based design. That is fine, But just killing the whole community, not having that kind of experience at the moment, this will gradually go up, I mean, over time. So this is the summary of all the things I have said. So I'm not going to read all this again because this was the purpose for later on. We'll come back to this. But essentially, all the points that I've talked about.
Thank you. Thank you, Vipul. I mean, you have gone into great details in the intricacies of analysis, design and detailing. And there are a lot of points which you have covered. I would now request Mr. Girish Dravid. Actually, we have already exceeded time by about 10-15 minutes. So my request to all the panelists is to kindly stick to the time of 10 minutes so that we have more time for the panel discussion, interactive session.
When you had given me the starter, Alok, I told you that it will take more time.
Okay, no problem, no problem. You have covered. I'm sorry to put this because after all, end of the day, we intend to complete it in 2.5 hours. So it's fine because you have covered also a great area, very complex area, I understand. So now I would request Mr. Girish Dravid to come in. Mr. Girish Dravid is currently the director of one of the most prominent structural engineering firm, that is Sterling Engineering Consultancy Private Limited. He is responsible for many high-rise buildings in India. That includes the tallest building, I think, in India, 320-meter Palais Royal at Mumbai. More than 25 buildings with height more than 200 meters. 8 million square feet Dhirubhai Ambani International Convention Center, built in RCC and structural steel, and many other offices. So I think he's basically a tall building guy, and I look forward to hear from him. Over to you, Mr. Girish Dravid. Kindly put it in the presentation mode.
Yeah. Can you see my screen?
Yes.
Okay.
Yes.
Okay. So the format of the presentation is such that we were given some few chapters to concentrate on, and I believe I was the last one to choose, and I got to talk on chapter 9 and 10, which deal with foundations and non-structural elements. So being a structural engineer, when I look at this chapter 9, foundations, most of the clauses, they look to me to be prescriptive, and there is nothing that I as a structural engineer can add. As you know, I mean, so far all the speakers have presented some kind of theory or their opinions on equations and all those things, but here I may not be able to do all that because most of the clauses are prescriptive. I tried to talk to a couple of geotechnical engineers in Mumbai and ask them their opinions about these clauses, but they could not come back in time, or I don't know whether they have any explanation to these. So my task is really simple. I'm just comparing what was there in the old code, that is 2017 version, and what is being proposed. So most of the clauses here are such that there is no change as such. So if you can see here, the load paths and factor of safety, there is absolutely no change in the codes. And if you come to this geotechnical investigation, there is a slight change in the depth of boreholes. Again, I am not sure why this change has come in, but see, there is a the borehole shall have a depth of at least 1.5 times of estimated width of the tower footprint, which was there, subject to minimum of 20 meter in soil and a minimum of 15 meter in rock. Earlier it was 30 meter in rock. So I sort of agree with this. I mean, if you encounter rock in general Indian conditions, there is hardly a strata which is softer than that rock, at least in zones where igneous rock is present. So this is a change that I observed, which is acceptable. But what happens if there is a raft too? For example, if I have a building with 40 meter by 40 meter raft, does the borehole need to go to 60 meters? What is the logic? So some such answers need to be obtained from geologists or geotechnical engineers. And I believe that there should be two-stage exploration. When there is a preliminary exploration to know the stratification, and when the building is configured in the sense it is planned, you know the number of floors, you know the loads that are going to act, and then how many basements are there, where the inherent foundation is going to be laid at which strata. Then there should be a detailed soil investigation at that level is what I would recommend. In fact, many a times this happens in our cases when we find that initial geotechnical report is not addressing the issues that this particular building requires. We do get into second stage of investigation. So again, there is no change in depth of foundations. It is exactly the same. Then I'll go to modeling of soil. Yeah, this is quite important. And Mr. Vipul Ahuja did talk about the need to model the soil with spring constants and all that. So this clause is quite important and it is present. So there is no comment about that as such. This clause 9.7.2, see this these load combinations have been given for pile draft foundations. So I wonder why the same are not applicable for raft foundations. I don't know. And then this line is added where X and Y are orthogonal accession plan. That is just a typographical addition, which was anyway amended in the amendment number 1 to 2017 version. I feel that raft foundation without piles also should be covered in this clause. So pile draft, that word, or should be just raft foundations, or you can add raft without piles. No change again in the settlement of foundations. The limits are exactly the same. Again, they are reasonable, and we have found out that in certain conditions these limits really are reached in soft soils and rocky soils as well. So that was foundation. I don't see any particular thing to discuss again because those are prescriptive clauses. And coming to non-structural elements, Mr. Vipul Ahuja has covered a very important thing about acceleration at a particular floor given in ASC 722. Basically, there are no major deviations. Coming to this equation, this is what Mr. Ahuja was talking about. And in fact, he interacted with me today morning or yesterday. And then I went to ASC 7 and actually saw that that new expression in ASC is really more relevant than this. So our code committee should look at this expression and attention should be given to ASC 7. No other change that I see, except that table numbers have changed. Of course, all readers might have noticed. I think that this Indian code for tall buildings, it is specifically written that this code has been circulated to members of Civil Engineering Division Council and Special Structures Sectional Committee. But all us structural engineers always face a problem in convincing architects or clients or MEP consultants that we have to use this code. Although prescriptive, there are certain theories behind them, and also there is experience, there is judgment, all that is there in following this code. And because some of the dimensional parameters which are prescriptive, again I'm telling you, which are prescriptive, architects should know before planning a building. So I don't know how this code can be taken to architects and MEP consultants. There has to be a mechanism. Either it should be part of NBC, like architects know NBC by heart and they try to follow NBC as such. But if this is a special code which is going to be used only by structural engineers, I think there will be problems in practicing this code. So this is something that all fraternity has to take up. My other things, of course, I'll talk when the panel discussion starts. Thank you.
Alok, you are muted.
Oh, sorry. So I just thanked Mr. Girish Dravid for, finishing his part before time, in fact. And I think all the points well covered. Now I request Ms. Sangeeta Vij, our founder member of IAS Shakti and a governing council member of IAS Shakti, I think, since its formation. Ms. Sangeeta Vij is a very well-known civil engineer from my own college, Delhi College of Engineering. And she is MTech from IIT Delhi. She spent 34 years in the building design industry in senior management roles. She's a managing partner of SD Engineering Consultants. And also she has worked as Deputy General Manager in RITES before starting her engineering consultancy firm SDEC. She has also worked as Director Technical at AECOM for a couple of years, handling prestigious high-rise buildings. Focus of her work has largely been earthquake-resistant design and rehabilitation of old structures to bring them at par with current earthquake codes. Her firm strives to improve long-term performance of the structures by adopting appropriate design and detailing techniques. So over to you, Ms. Sangeeta.
Thank you.
I think
Alok,
you have
thank
10
you.
minutes.
Yes, I know that. And I've been working now for 40 years, so small correction.
Okay.
And I would love to bring everybody's attention towards clause 11, where I don't see any major change from the earlier code. This is what I'm showing you in the draft, which has come out for revisions. And I think it is important for us to note that the guidelines for approval process for design of concrete tall buildings not conforming to the prescriptive requirements of this standard. This is a very, very important subject, which probably most of us may not have looked into in detail, because we may have thought that, okay, this is this is code exceeding and we are not working on any code exceeding projects. So I want to bring your attention to this special table here, which lists out a generic format of checklist for code exceeding buildings. Other than the table, there is in this annexure a very well-defined structural design review process, and the composition of SDR panel, which Vipul has already pointed out that probably the qualifications of the SDR panel members may be reviewed before the draft goes out for circulation, as most structural engineers that I know of may not qualify for, having done 10 buildings more than 150 meters tall. That I think is a bit tall order. Then there is a very, very detailed description of what kind of submittals need to go to SDR panel, and what are the requirements which need, in the review process. What are the focus areas where the review process has to look into? However, I don't see any major revision here, and I don't see any particular area where I would love to talk to you except this table. Now, please patiently allow me to read it out to you, the conditions that we are talking about. these clauses are defining which project is going to be a code exceeding building. Is the building height greater than 250 meters tall? If the answer is yes, it is a code exceeding building. Similarly, if the building is located less than 10 kilometers away from any seismogenic fault. Now, whatever explanation our learned professor gave in the beginning, I still feel that it is humanly impossible for me to determine if my project, let's say in east of Meerut or East Moradabad, whether it qualifies to be in this category or not. Still, we do not have a reliable published data for me to be able to pinpoint and prove to my client that yes, this building is now a code exceeding building. So I think we need to have more information published, more authentic information. Maybe BIS can add a couple of graphs to the code, or bring out an annexure listing out or showing pictorially the seismogenic faults, by way of which we should be in a position to locate our project on that map and check whether it lies in that 10 kilometer region or not. Now, if the building houses more than 20,000 occupants, it is a non-code exceeding, it's a code exceeding building again. And does the building have any transfer structure? This, my dear sir, everybody knows that there are thousands of buildings all over India where transfer structures have been provided. Now, do we understand that the transfer structure in a building automatically makes it a code exceeding building? If yes, then I have multiple examples in my mind. In Gurgaon, in Noida, we have buildings where transfer structures are supporting 5 or 6 floors, connecting two very dissimilar buildings, tall buildings, and that really qualifies for that. Does the building structural system exceed the height restrictions specified in Table 1? Now, I don't know whether all of us are familiar with this Table 1, but this Table 1, for example, tells us not to use a moment-resistant frame in Zone 4 and 5 for buildings which are more than 50 meters in height. Now, how many buildings do we know of personally? Maybe in thousands, which will fall into this category, which now has become code exceeding and needs to go through a SDR panel review. Now, does the building slenderness ratio exceed the requirements specified in Table 2? Does the building exceed plan aspect ratio? All this has been covered earlier by Professor Tandon. And if you want, I can quickly take you to this Table 1. Just give me a second. Table 1, I feel it's important for us to see this, that in Zone 4 and 5, moment frame is not allowed, not applicable. And structural wall systems also, the height has been restricted in Zone 4 to 150 meters and 120 meters for in Zone 5. Similarly for various structural systems. Number 2 table gives the maximum slenderness ratio, which is the height to width ratio in a building. And personally, I think I've seen buildings exceeding these slenderness ratios mentioned in this table. And I'm sure most of us may have come across buildings in that category. Similarly, in the plan aspect ratio, the maximum length to width ratio of overall building should not exceed 5. So if the answer to all this is yes, then definitely our buildings will fall into the category of non-exceeding buildings. Now, this, my dear sir, puts all our buildings into a danger zone or a zone where we need a special review, even for existing buildings. Although the code does not give that mandate for existing buildings, but I'm sure all of us are genuinely concerned about the non-conforming and the code exceeding buildings, which are already existing. Now, we were looking at the plan aspect ratio. Next point is the lateral translational stiffness of any story less than 70% of the lateral translational stiffness of the story above. I don't want to talk more about it. I think we've seen ample number of buildings, especially these tilted buildings dotting our landscape in NCR. Even in zone 5, I've seen buildings where tilted floors have been constructed. And even though the height of our metro stations may not be 50 meters or above, but most of our elevated metro stations fall into this category here of, clause number 8. Is the lateral translational strength of any story more than that of story above? If the answer is yes, again, it's a code exceeding building. Is the inter-story elastic lateral drift ratio theta that we've seen, does it exceed the specified limit as per clause 5.4? If yes, it's a code exceeding building. Is the first or second natural mode of vibration a torsional mode? My God, I've reviewed personally so many buildings where we had to point it out to the designer that the building is going into torsional mode in the first mode itself. So I think this is a very important clause and all of us must take note of it. Is the fundamental translational lateral natural period in exceedance of the specified limits as per 5.5.2? If yes, well, we need to be concerned. For a precast floor system, is the structural topping thickness provided less than that specified requirements? Well, till this point, if the answer to any of these clauses is yes, the building is a code exceeding building. Now we go to floor openings as given in clause 5.6. There are very clear-cut guidelines about the limits to floor openings in the floor diaphragm for the floor diaphragm action to happen. And if the openings are not conforming to the requirements, then again it becomes a code exceeding building. I think by going by this criteria, most 5-star hotels, immediately it strikes me, may fall into this category where we have like 3-storied or 4-storied reception. And in case our structural concrete is greater or equal to M30, if it is not, then it's a code exceeding building again. So how many buildings do we know of which were designed with less than M30? I think there may be plenty. Is the wind tunnel study in conformance with specified requirements as per 6.2? If no, we need to be worried. In seismic zones 4 and 5, is the design based on deterministic site-specific design spectra? Well, the answer may be no to many projects, just simply because in India, we still do not have this kind of data available for any major project happening. And I don't think we are given, as structural engineers, we are given ample time to do more R&D and come up with the reliable site-specific design spectra. it definitely needs more research data to be available. And next clause is the design based on crack section properties as noted in table 6. Well, I think we all agree on this, and I don't see any problem. All of us are following this. And is the stability coefficient less than or equal to 0.2? If not, it's a code exceeding building again. For project with multiple towers connected with a single podium, are the requirements specified in 8.1.3 satisfied? Well, I think the most serious drawback that I can foresee here is that you have to do double analysis, if not more, as Vipul pointed out, that you may have to do 2 into 2 times analysis, one with towers separately and the other with all the towers combined with the podium. I doubt if our systems are geared to handle this complex model and run it also. It may take days altogether to complete the structural analysis of one such project. Where moment structural wall system is provided in zone 4 and 5, are the special moment frames and shear walls continuous? Now, I think we need to deliberate a little more in the committee on this clause, because in table 1, we have simply categorically disallowed moment frame system. And if we are allowing a system where moment frame and structural wall system is sharing the lateral load, we may need to either specify at least 75% as given in 8093 part 1 to be shared by the shear walls, or make it clear as to what ratio of sharing will be acceptable. And these are again the criteria for wall thicknesses. As Vipul pointed out, 160 may not be the right thickness as the minimum thickness. And if not, if the openings are not as per 8.5.2, if the nominal design shear stresses in walls are not as per 8.5.8, and if the longitudinal reinforcement ratio in coupling beams is less than limits specified in table 7, and if in projects in zone 4 and 5, are the requirements of 8.5.14 satisfied? If the answer is no, we need to take another look, revise our analysis, or be prepared for SDR panel review. So again, we have a clause where we are talking about the lateral load carried by the shear walls in a shear wall flat slab system. I feel we should deliberate a little more on this and make it very clear that in case it is not, if it does not meet that criteria, do we still allow the flat slab system to continue? Or do we not allow the flat slab system to continue? So where frame, tube, or in-tube system or multiple tube system is provided, is the plan shape of the system regular? Is length to width ratio less than or equal to 2? If the answer is no, again, it's a non-exceeding, it's a code exceeding building. And is the geotech investigation completed as per requirements of 9.3.1? And is the minimum depth of foundation provided as per the recommendations discussed earlier by Vipul and Girish Ji? Are the estimated design settlement values within specified limits? Alok, how much time do I have?
Sangeeta, you have already exceeded your time, but you please continue.
No, I would like to simply conclude here by making two very important comments. One is, who is going to tell the owner that his project is a code exceeding project? Number one. is there any authority with the local authorities? Is there any power that has been bestowed on the local authorities to be able to guide a particular project owner? And I think implementation of these clauses is now it's very clear that implementation is not going to be easy. So we have to devise a strategy by which these points are taken care of in the implementation. And as earlier pointed out by one of the panelists, I think Rishi pointed it out, that architects are usually not familiar with the earthquake codes and they don't want to be familiar. I told you in another meeting earlier that when I pointed out irregularities in the geometry to an architect of a particular important project, he got clearly very offended and he told me I had no business trying to tell him how to do his work. So now the most crux of the whole thing, the whole geometric planning, the ratio of height to width, the aspect ratio, and also primarily the structural systems, if beam columns can be adopted or cannot be adopted in a particular building in a given zone. I think we need to somehow involve either the structural engineer in the geometric planning at the initial stage itself, or the architect into the issues that we are discussing today. I don't know how it will be done. I'm just throwing the floor open and throwing the points to my colleagues here. And thank you very much for your attention.
Thank you.
And questions are welcome.
Thank you. Thank you, Sangeeta. I think you have brought a very important point. Annexure A, which definitely is a very, very controversial annexure. And I'm sure it will be discussed in the interactive session. I now invite Mr. Abhay Ghate, who is the last panelist, to talk about the last annexure, though it is the one of the most important annexure, which is Annexure B. And let me introduce Mr. Ghate first. Mr. Abhay Ghate is actually he is attending this webinar from US, so it must be around 6 o'clock, 6 a.m. in the morning. So thank you very much, Abhayji. He is presently the chairman emeritus of Optimal Consultancy Services Private Limited. He has designed several prestigious projects in India and overseas, like in Bahrain, in UAE, Indonesia, Sri Lanka, Bangladesh, and Singapore, many buildings. He has worked on structural design of hotels, hospitals, oil and gas structures, jetties, steel plants, textile mills, chemical plants, high-rise commercial and residential towers. And is a very well-known personality in the structural engineering fraternity. He has received several recognitions in Optimal Designs, and he is a founder of Optimal Design Consultancy. And over to you, Mr. Ghate, for your presentation. Kindly share your presentation, sir. Sir, you have this green button below. Share screen, green button.
Yeah,
you just press. Yeah, we are getting it.
Are we getting?
Yes, yes, it's visible. Just you can make it in the presentation mode. Yes. Yes, sir.
But I'm not able to get the slides.
We are able to see your PPT.
You're able to see?
Yeah, we are able to see, but kindly make it in the presentation mode.
Mr. Ghate, we are seeing your last slide.
Yeah, now you are seeing the first slide.
But why we are not able to share the screen?
I think if you see at the bottom, you have this, bottom right. You can click that after the bar for presentation mode.
Yeah, I know. But it's not taking up,
No problem, no problem. I think we are able to see your screen, so
Yeah.
you can continue.
Okay, let me start with this,
Yeah.
That I mean, this is one of the good codes, and notwithstanding the comments, after the comments are incorporated, I would say it should come out to be quite a good code, My first comment is actually on the recommendation. The plan should have an automatic batching and system with this thing. My comment is that plan should have an automatic batching system with moisture sensing equipment, and also the microfine materials also should be auto batched. See, many IOC plants have auto batching, but at many places we found that GGBS and microfine materials like alkofine get added manually. My second comment is on the concrete strength at 56 days. Now, generally, the strength at 56 days is more than 28 days strength for mixes with GGBS and flash. The random results may vary, but statistically we get much higher strength at 56 days. If we consider 56 days strength as design criterion, significant economy can be achieved in the mixed design. The point is at what stage we need the strength. If we can get the strength in 56 days when the structure is not loaded fully, we can use 56 days strength as the design strength itself. The other comment is in the code it is mentioned, in the draft code it is mentioned that we should start water curing immediately. The experience is the use of if it is observed that for pours of mass concrete, the immediate water curing needs a high temperature gradient, and the best option would be used to insulated sheets to cover the concrete initially. My last comment is an important comment here. And durability and sustainability of concrete cannot be overemphasized. The draft code has rightly stipulated some tests, but limits of durability will vary depending on the location and the exposure condition. Project consultants should be allowed to change these limits. Of late, some cases of chloride contamination have indeed occurred in Mumbai, Delhi, and Gurgaon. Some of the structures required large-scale retrofit and some had to be demolished. So these are the most important tests which have been specified, and we have been using it in most of our projects in India and overseas. And we do get high quality impermeable concrete, reducing the waterproofing requirements significantly with this specification. In fact, in retaining walls, we need to treat only the construction units for water protection. Here again, we suggest that 56-day strength should be used in RCPT and all other tests. We have suggested 2 more tests in addition to this. One is water absorption test, that's for BS 1881, which is not there in Indian code right now. And there's a new test called rapid chloride migration test, which is a Norwegian test, which overcomes the problems encountered in RCPT. Now this the new test, rapid chloride migration test, has been introduced in Mumbai Trans Harbour Link project. We need to do some more research on this, but I think it's a welcome change to specify all these tests, and the code has done an excellent job in this. Thank you.
Thank you. Thank you, Mr. Ghate. I think with this, we have heard all our expert panelists and covered all the clauses. And now I open. Can you please stop sharing, Mr. Ghate, so that we can start the discussion now, interactive session. And the structure of the interactive session will be will be almost similar. That means we will go clause by clause, and we will invite comments from the panelists, as well as we will see the Q&A box. I request all the panelists to kindly have a close look on the Q&A box, and when we discuss about a particular clause, if there is any specific question which the panelists, any of the panelists wants to take up, most welcome. Otherwise, let me now start sharing my screen, and I will open the code itself, so that we can discuss clause by clause the provision of the code. Just give me a moment. Are you able to see my screen, or
Yes,
not
yes.
yet?
No, we can see your screen. You are searching something on computer.
Okay. I think let me, I don't know why it is not becoming visible. Maybe there are too many things open. That is why I'm not able to show that. Or if anybody can open the code. Sangeeta, would you be kind enough to show the code, please? Can you please share the code?
I think it is visible now. If you're
Okay.
Yeah.
Okay, fine.
It is visible. Okay.
It is visible. So let me start with, let's say, first clause. I don't know why it is running so. Is this my, no, it is Sangeeta who is doing it, I think. Sangeeta? Yeah.
Yes, it
Thank
is
you.
my screen. Yeah. So you keep.
Yeah. Okay. So can you just show the first clause number 1, that is scope?
Yes.
We start with clause number 1, which is scope. And if any panelists having any comment on the first clause? Well, if there is no comment, then I have some comment. If you see clause 1.3, it says that this standard is applicable only for buildings that house 20,000 or fewer person. Now, I am not clear as to how this number of 20,000 has come. If any panelists can throw some light on that, because my understanding is your maximum limit for this particular code is 250 meters. And if you take, say, residential building of, say, average height of 3.5 meters, then you will get something like, say, 70 stories. And per story, if it is, even if it is an office, you can accommodate maximum 80 to 100 people per story. So if there are 70 stories, you can at best accommodate 7,000 people. 220,000 is a big number, and I don't know where from it has come. If any panelist or anybody can throw some light. Okay.
Obviously, they are talking about larger floor plates here, and this is the probably the upper limit that they are talking about.
Yeah, but Sangeeta, 20,000 would mean how much per floor? If there are 70 maximum, take the maximum height, 70 storied. I mean, it is a huge number,
70 storied.
I mean,
70
you see,
storied hai, I know, but if the floor plate may be big, it may be bigger.
Oh,
It may be 80 meters by 80 meters, 100 meters by 100 meters.
But what is the logic behind this number?
Logic behind the number is only to be able to contain the damage if at all,
I
that
think
happens to such a massive structure.
Can I?
Yeah, Tandon Sahab, yes.
You see, if you have a common basement and you have a number of towers in a project, and these days the basements are extending in the entire area that the builder has got. It's just the whole thing is a basement, and then it has got several towers. If you are thinking of designing, like somebody, I think Sangeeta only mentioned that it is impossible to design those, to analyze those type of things. But in those type of issues where you have a number of towers and the basement, if you are counting them as one structure, it may exceed 20,000.
So that requires a clarity in the code,
Alok,
whether in such situation we would like to count all the towers or a single tower. That also requires a clarity.
Again, there is one. I have one confusion in this. Alok, can I say something?
Yeah, sure.
In 1.3, they say that the standard is applicable only for building that house 20,000 or fewer persons. Does it not have any relation with the height? अगर इसको खाली we read this sentence 1.3, it means if I have any building which has a much higher height than the 50 meter and the number of persons living less than 20,000, so does it mean that this code will not be applicable?
Oh, if it is less, then it is applicable. If it is more, then it is not applicable.
नहीं वही तो मैं कह रहा हूँ, अगर हाइट ज्यादा है सपोज 50 मीटर से और ये 20,000 से कम लोग हैं उसके अंदर, तो क्या कोड एप्लीकेबल होगा या नहीं होगा?
हाँ है ना, वो 1.4 में दिया है ना, उसने क्लियर किया है। वो तो क्लियर है ना?
वो क्लियर है।
उसमें कोई एम्बिग्यूटी नहीं है।
I think the background what Tandon Saab mentioned it may be the correct interpretation, but in that case this clause needs a little more clarity. When you have series of towers with a common basement, you are supposed to count all the towers put together for satisfying this clause and not a single tower.
But
if that is the intent,
I think this 1.3 and 1.4 को भी साथ में क्लब करना जरूरी है.
I think we should, in my view, 1.3, even if it is deleted, it does not affect the code in any manner, in whatsoever manner, or it needs little more elaboration if there is a background as to why.
It is creating confusion actually.
Okay, my second point. Yeah. So can I continue, please?
Of course.
I have a point here.
Okay. Yes, Vipul.
Basically, in ASC 7, there's a figure which is shown, which is C1.5-1, which is a commentary for this, where it shows about the importance factor. Okay. And it shows the number of people at risk, and then it also shows the the category, risk category 1, 2, 3, 4, based on which actually there is these importance factors have been defined. So and that category is like from 1 to 10 and 10 to 100. It goes on a log scale kind of a thing, and then the chart goes up to about 1 lakh. And between 10,000 and 1 lakh, it is risk category 4, okay, which will be important factor 1.5. So maybe somebody has picked up this, from a similar chart somewhere, is what I can imagine.
Okay, so can we move forward? If you see now clause number 1.5, there are several nomenclatures given, and Professor Tandon mentioned that probably a sketch is better. It would be better if we use nomenclatures which are standard, commonly used. But what I find is in this there are many which are covered here, mentioned in this, but if you really go into table 1, table 2, those do not exist. For example, here if you see this frame tube system, tube in tube system, multiple tube system, all these things are not covered adequately in table 1 and table 2. Whereas it is mentioned as if it is a part of the scope. If it is in the scope, then Sangeeta, if you show table 1, should it not figure in also table 1 and table 2 as to what are the limitations of height in those building types?
Alok, for that, Tandasa was saying that we need to change the nomenclature of these structures.
That is number one. That is one.
No, just a minute. I believe that they have followed the system, I think, which is given in IS 1893. More or less, they have taken the same nomenclature here in this code also.
So any other view?
You see, when we are talking about tall buildings, this tube and things like that, that is where they come in. They
Yes.
don't come in normal kind of a
Correct. So they are not
that-
there in 1893. Manoj, they are not there in 1893.
They are here. No. They are certain structural systems which are there in 1893. They have taken the same nomenclature here, and which are not there, they have added some more system in this code.
Right, but the point remains that those additional structural systems should also find a place in table 1 and 2.
That's
and
what
3.
I'm saying.
That is a very valid point, and we should. I hope somebody is recording our comments, Alok. How are these comments going to be conveyed?
I'm recording.
You are recording. Okay, good.
Okay, so if there are no other points, then we can go to the next clause. Next clause, I think clause 2, 3, they are all, terminology. We can straight away go to clause number 5, I think, because clause 2 and clause 3 are all related to, symbols and references, etc. So we can go to the operating clause, which is clause number 5. Any view from any of the panelists on, we have heard Professor Tandon on clause number 5 and 6, but if other panelists would like to share their comments on these clauses, then I think this is the time. And also I request all the panelists to kindly have a look at the Q&A box. If there are any relevant question related to this clause, then maybe that also can be taken up by the panelists.
Can I say something, Alok?
Yeah, for sure.
भाई मैं तो ये कहना चाहती हूँ कि जो बिल्डिंग्स ऑलरेडी बन गई हैं और ये सब टेबल 1, टेबल 2, टेबल 3 एस्पेक्ट रेशो नहीं मीट करती हैं, उसके लिए कुछ मैंडेट नहीं है इसके अंदर. तो डू वी एक्सपेक्ट these existing buildings to also go through the SDR review? Who's going to initiate this, or who's going to bell the cat, as I would bluntly like to put it? So yeah. I personally know umpteen number of buildings which had actually suffered a major damage, during even Afghanistan earthquake, those flat slab buildings without shear walls. There are plenty of them in NCR. So every repair was done in a very hush-hush manner. But who's going to bell the cat? The list of non-compliant buildings is increasing every day.
Sangeeta, may I butt in here?
Of course.
I think in my view, this is not the purview of this particular code. This is a code for design of new buildings, new tall buildings, and not for the existing building. What you are saying is a point well taken, but I don't know if other panelists can also share their view on this.
No, I think we should have a separate discussion on what to do about non-conforming buildings.
Non-compliant buildings.
Yeah. Non-compliant buildings, like Sangeeta has already said that there are thousands of them and they are springing up every now and then. So what to do about those? I think we should have a separate discussion.
Yeah. Now let's come to clause number 5. I have one very minor comment on clause 5.7.1. Sangeeta, if you can just show that. 5.7.1 talks about the minimum grade of concrete. and it is stated to be, minimum grade as M30 and maximum grade as M70. And I have comments on both. In my view, M30 is too small a grade for, when we are talking about tall buildings. At least the least I would expect is M35 grade of concrete and not M30. And second, also on the maximum grade of concrete, I don't know why we should restrict to M70 in today's scenario when, when we are talking about 250-meter or you see high building, 70-story. Surely we can go for a higher grade of concrete up to M80.
No, they have permitted. They have
Higher
permitted.
grade is allowed, Alok, in
That is
annex.
allowed.
It's
In
not
annex,
allowed.
they are allowed higher grade than M70.
No, no, but with a rider. You see that higher grade is with a lot of rider. My
Yeah,
point
but
is,
they are allowed higher grade. In fact, the word maximum grade, this is a bit conflicting with an annex 2,
right. So,
Yes, so it says over here, hello,
Huh?
that clause it says when higher grades are required, the designer shall ensure thorough experimentation that such concrete shall have at least minimum crushing strain.
no, but that clause, the second sentence is contradicting the first sentence.
No.
The first sentence itself kills the second sentence, no?
No.
No,
I think
they are saying
that
it-
language maybe they can, code writers can
Yes.
talk about changing the language over there, but the intent is very clear that when higher grades are required, then you ensure this.
But if required more than 70, then you have this kind of a condition.
Yeah, then your strain has to be.
No, but the first sentence cannot be the maximum grade of concrete shall be M70. The moment you say this, I think there is no scope for any further. I mean, what
So
I think
this
if the
is a
intent,
conflict. There is a conflict
Yeah.
there, yes.
there is a conflict, and if the intent is that yes, desirable is 70, and but if you want higher grade, then you have to do this, then it is fine. The language needs to be changed. But
Yes.
I'm not sure whether that is the intent here. I mean, if that is-
इंटेंट तो वही है, इंग्लिश लिखने में गलती हो गई होंगी.
Okay. Also, I think in general clause, that is clause number 5, I have one observation which is not there in the code, but my feeling is, one important thing has been missed here, because when we talk about design of tall building, somewhere we should have mentioned in this code that, planning, design and construction of such buildings is a kind of multidisciplinary activity. It is not, I mean, it is written as if the structural engineer has to design a tall building and give it, and that's it. I think a lot of emphasis is needed to be given, in my view, in clause number 5, which is general, to talk about the interdisciplinary activity like, electrical, mechanical, water services, fire, ventilation, and a need for coordination between the various disciplines. I think that, in my view, in some way, in the general design features, should have appeared. Because you see, the whole the construction sequencing, the technology for pumping of, even including the architectural design. I mean, the structural engineer has to be completely familiar with the functional requirements, and the architectural design has to understand that, there is a concept of a operating floor, service floor, somewhere in between, in the intermediate level. All
That
these
would
things.
that would come in National Building Code. Why would it come in this code? National Building
But
Code.
don't you think that in a structural design code, we should at least give a cautionary note on the interdisciplinary interaction, which is absolutely essential for tall buildings?
Sure.
What is the view of the panel?
Well, the cutouts are addressed already in this verbiage somewhere.
No, but I think that if what Sangeeta was saying, the aspect ratio, the height, the slenderness ratio, if that is all wrong, whatever the architect has conceived, then what is to be done?
So other than this, even the plan geometry, the elevational planning, everything can actually lead to first mode going into torsion. We've done reviews of many projects, or even in certain lower height structures, we had many problems because of the first mode getting into torsion, because the geometry was so irregular. But the architect there is completely not interested in solving your problem or helping you out. He just tells you, boss, this is your problem, your baby, you handle it. So it becomes unmanageable, and especially when taller buildings where you have these open type of configurations. In residences, you have a common central core, and the other flats are like petals of a flower. In those cases, these flat wala towers tend to act as independent towers. So it becomes really difficult to control the drift and also design the connecting elements. It really becomes a challenge. In one of the projects, we had to provide I sections in the beams to account for the exceptionally high shear in the connector beams. So, all the problems that we face as structural engineers, architects are not interested in looking at the source of those problems. बट हु इज गोइंग टू रीड द कोड? आप इस कोड में डाल भी दोगे तो आपको लगता है कि आर्किटेक्ट इस कोड को पढ़ने वाला है या एनी कंसल्टेंट इसको पढ़ने वाला है?
Okay, Manoj, you wanted to say something.
Alok, just I wanted to say one thing. Yes, I do agree with Sangeeta that in this code there should be some clauses, or at least one or two clauses, where we can put some condition that if architecture plan, geometry or shape do not conform to this, then that should be revised. There should be some condition on that. So some such condition should be there in this code.
No, I see, Manoj, my view is that don't put it this way. My view is we put it the other way. The planning, the architectural planning has to have interaction with the structural engineer
Alok,
for tall buildings.
नहीं, nobody will have ना वो implementation नहीं होता उसका ना, वो हो नहीं सकता
नहीं, but code में अगर if it is written in black and white, then it will become mandatory.
Architect do not know anything about these code. They do not want to read anything. They just want to have this FAR and setback, and that's all. They are not bothered.
I think Manoj has made a very valid point that we should make a provision for rejecting the architectural approval itself.
In certain
cases where the irregularities do not conform to IS 1893 Part 1 tables. Yeah, there are very clear-cut guidelines. At least those should be.
Sangeeta, my view is that may not be practically possible, because after all, this code, the code is only a kind of, it's not mandatory. It's not legally binding.
It is mandatory. It is mandatory.
It will become mandatory as far whenever it will be notified and it will written the building bylaws. If you have to design,
No. Please look at the screen, Alok. Please look at the screen.
This code
go to 5.2.1. Look at the screen. It says plan shall preferably be rectangular or elliptical in buildings with said plan geometries. This is happening. So we have to have some kind of a clause where we make regular geometry mandatory, at least for beyond a certain height. I think we must not allow architects to take a flight of fancy and then put a noose around the structural engineer's neck.
Anyway, I have a different view on this, because if you see the different kind of buildings which is coming up all over the world, all these buildings are twisted with all odd kind of geometry. You are
वो earthquake area में नहीं है.
Allow me to complete.
वो earthquake areas में नहीं है.
Allow me to complete.
आप टोक्यो से क्योटो तक जाइए, सब regular geometries मिलेंगी आपको.
You can see many buildings even in US and in other earthquake prone areas. So issue is not whether we permit or not permit the irregular buildings or a twisted building. The issue is how to design it. We cannot design with IS 16700, which is a prescriptive code, a building which is irregular. We need to upgrade our code rather than say that because our code is limited, so the structure has to be, geometrically linear, prismatic, and nothing else can be permitted. I think that is a little, in my view, a bit of regressive stand.
No,
Rather than
I don't
saying,
agree with you.
anyway,
आपको
okay, so
रिग्रेसिव लग रहा
I would
है
like
पर
to,
ऐसा है नहीं.
I would like to hear others also on this.
Can I come in, please? Girish?
Yeah, sure.
Yeah. See, Sangeeta, can I share my screen?
Sure, sir.
See, what is happening here is, so it all boils down to authorities. So in Mumbai, we have a very strong association of structural engineers. We are all friendly and we take up issues with the municipal corporation. And you can see this GR. This is April 2021. And this is expert review panel committee appointed by municipal commissioner. All the names are there: practicing structural engineers, academic experts, geotechnical experts, base isolation, and department experts, other experts. So this committee was formed in April 2021. I'm one of the members, as you can see, number 3. My name is there. And we started functioning, and initially there were a lot of debates, but now we have formulated an action plan. Again, we went back to the municipal commissioner. Now, can you see my other document which I'm presenting?
Yeah.
Yeah, okay. So there is a procedure set up. So what I'm trying to say is our contention of architects not agreeing and all that immediately, is dissolved when this particular GR came in. The building proposal department asks the structural engineer itself to fill that checklist and asks whether that building is code compliant or not. If it is not, then by law, it has to go to high-rise committee or expert review panel. This is the law in Municipal Corporation of Greater Mumbai now. And we have started reviewing these buildings, code exceeding tall buildings. Everything is written here. And this is exactly expert review panel originates out of IS 16700. Now, every architect in Mumbai who practices in Mumbai knows about this code. And even if certain aspects are beyond the code, there is a provision for reviewing by ERP. So we can have twisted buildings, we can have inclined buildings. Code doesn't stop you from designing any irregular buildings. It has to be, it has to satisfy all the performance criteria. That is the whole idea. So if Delhi or NCR goes to authorities, you people should go to authorities and tell them that there is a requirement by this code to make it mandatory. Every architect, every MEP consultant now knows about this code. This is what I want to tell you. And in Mumbai, we are very comfortable as structural engineers. Every architect first asks us, he sends us the preliminary plan, he calls us for the preliminary meetings. Sometimes we decide the structure and then the architect starts his work. So it's not difficult if authorities step in. That's it.
Okay. Any other view on this?
Yes.
Yeah, Tandon sir.
I think we are headed in that direction because.
Take a minute, Vipul. Just let Mr. Tandon speak first. Then I'll come back to you.
What I think is what Alok said. Just to expand that a little bit, we cannot put that this thing has to go here and there and all that. And when the municipal corporation will agree, not agree, I think that's a separate issue. But what we can certainly put here, that at the concept stage itself, the coordination between the structural engineer and architect has to be there, and both have to sign some plans or something like that. Because if there is no if there is coordination in the concept stage itself of the design, where the architect has not already put doors, windows, he won't change it at that stage. But if you tell him right in the beginning, there is a chance that you may be able to get some of your ideas through. So that is what we need to put in this code. You can, of course, as a parallel action, by all means, go to the municipality and things like that and see whether they agree or don't agree.
See, I
Also,
We
yeah,
need to
Vipul.
have a panel in place.
Vipul,
See,
you wanted to say something.
yeah, I said, Professor Tandon is absolutely right. In theory, that's a very good scenario, that the architect automatically listens to the structural engineer. But I think it requires more than just this theoretical outlook, because the real world is very cruel over there, where it's the reverse is true, where the architect actually prevails upon the structural engineer in most cases, and it's backed 100% by the client, and they want the building to look a certain way. Then that's how they will have it, unless the structural engineer has a backing of a law, a strict jurisdiction, and a stick on his head that the review panel or the peer reviewer will not allow it, and that's the stand he takes. Without that kind of a backing, I've seen a lot of structural engineers buckle to the pressures of the clients. We need that, and Mr. Javed will also agree that before this ERP came in, could they have taken a stand like that?
Can I say something here? I think
Yeah.
At a concept stage, as Professor Tandon has pointed out, if we go to the architect, and most of the architects discuss concept with structural engineers, my experience is they are open to suggestions, and we can do architecture tweaking. We can suggest to what kind of system we should adopt and what is the best system for this, and they're patient enough to listen to that. Actually.
Yeah, so, but see, finally they'll hear you. Everything will happen. But in the final meeting, they will, in which the structural engineer is not involved, the client will prevail upon the architect and say, no, I would like my corridor to run through this wall, and that's how it is going to be. That's the way I'm going to be able to sell this building. Otherwise, I'm not going to be able to sell this building. The marketing fellow will come in from the client side, and he will say that I can't sell these flats with this kind of a layout. And that's the end of that.
Mr. Ghate, I also would like to add something here, that in our kind of world where we work, the structural consultant gets changed overnight if he raises points where architect is not comfortable. And architect does not, it is beneath his dignity, so to say, or beneath his ego to discuss with a structural engineer at the concept stage, because he is always trying to bring, he has this concept that he is doing a great service to a client by translating his dreams into reality. And the client may have got some pictures from London or wherever he fancied a building, and he wants the architect to translate that, build that for him. Now, whether that is doable in India or in a particular city, whether it is Shillong or Guwahati or Delhi or wherever, the structural engineer, ultimately it becomes his responsibility to translate that into a safe structural system. कोई पूछता नहीं है structural engineer को. Let me tell you, be very frank with you.
Yeah, Delhi, now I think gradually the scene is changing, because Haryana and UP have adopted this new impact procedure, and
वो भी चिंतन के बाद हुआ है ये सब. थोड़ा होना शुरू हुआ है, पहले नहीं था ये.
Maybe it will take some time, I think, before the structural engineer will be.
I think, Vipul, I think we have other clauses also to discuss. Let's move forward. We will come to annexure. When it comes to annexure, we can discuss this. But we are just at clause 5 only. So let's move forward. Clause 6, any comment from anyone in the panel?
Alok, do you want me to share the screen?
Yeah, kindly. Thank you. So clause number 6, if anybody has any comment, loads and load combination. Okay. I only have a few comments, if you allow me. Then maybe clause 6.3.2. Clause 6.3.2, you see, I think, there is a term for building seismic zone 5 deterministic site specific design spectrum may preferably be estimated. I think this language preferably in a code is not a good word, because either it should be done or it should not be. If you keep it preferably, then it becomes a problem. In my view, it shall be, may preferably can be replaced by shall be. If I don't know, maybe Professor Yogendra Singh ji can comment on this.
Yeah, I mean, I agree. One is the preferable, and another thing is this deterministic. Why we are insisting on deterministic only?
Right.
Either we do not specify that site specific, or I mean, earlier our code was deterministic, but now we are in the hazard section of our code, we are moving towards probabilistic approach, and here we are insisting on deterministic. So that I don't understand. So that can also be perhaps pointed out by us, that this deterministic word should be either removed or it should be replaced by probabilistic.
Yeah. Sangeeta, can we move to table 4? Next page, I think. Sangeeta? I think, Sangeeta, are you there? Or we have lost your connection? No, she's there. Anyway, I think, I just wanted to mention that there is a table which talks about the minimum design base shear coefficient, a percentage of seismic weight. In my view, the basis for that minimum shear, though the code makers would know, but I think it is better to put it in the note, footnote below that table, as to what is the basis based on which that minimum base shear coefficient has been arrived at. What is the R value taken? What is the importance factor taken? There must be some basis on which these percentage acceleration coefficients are arrived at. So it would be better, though it is prescriptive code, but I think little bit of information should be, in my view, should be captured there. So we move to clause number 7, structural analysis.
I think on this one, Professor Yogendra Singh did mention in his talk a little bit about.
Yeah, he in his presentation, I saw some values given over there, but that is not reflected in the code. I mean, what I'm saying in as a footnote, it should be given for the user. They should be little more. They should not use code. Really, you are making them a blind user.
Actually, my comparison was from a different point of view. It was to show what effect the period will have, where the period will be governing or not. But how this minimum base year has been decided, I do not have any idea.
Okay.
But anyway, it's very less. It's not high.
That I agree, that these values are quite less. So not a problem.
Yeah. Sangeeta, are you there? Okay, so we move to clause number 7, that is structural analysis, clause 7 and 8, analysis and design. Any view?
In 7.1, I'm just wondering, Yogendra Singh may be able to answer this. The structural analysis carried out using standard 3D computer models using well-established analysis software. Like in the academic world, they also use a OpenC's software. So is that considered, that's a very flexible kind of a software, very powerful indeed, I've also heard. So is that a well-established structural analysis software, or is it something that,
Another my question is that this is BIS code, and in the BIS code it is written a well-established system. Now, what do you mean by well-established structural analysis software? इसका मतलब क्या है? It is subjective term.
Yes, exactly. So I am asking.
I think it should be validated software.
I thought BIS कैसे होगा?
So is OpenC's a validated software? Because all your graduate students, everybody works on it, and then some of them after coming out, they work on it.
So who's going to validate it, Alok?
No, generally these software. All the software developers alone ones, they generally.
BIS करेगा, कौन करेगा? This is, I think this needs review. This clause needs review.
I think it should also be added here that the latest revision of the software should be adopted, because most revisions of the code get incorporated sequentially. So if someone is using ETABS of let's say 2000 or 2002, that may happen in case people are using pirated versions, then they will not be able to give you a design compatible with the latest version of the code, because those have not been incorporated in those versions.
Well, the other flip side to this argument, Sangeeta, is, it's also very dicey. But if you say that you use only the latest version, what is defined as the latest version? At the time of the DBR, when that is written and frozen, that's the latest version of the code and the software. Is it, during the design process, after you've done half the design, or is it after you've completed half the GFCs?
So even the latest version of a particular software may not be incorporating all the clauses of the BI standards.
Yeah,
so,
I mean, that's a whole story.
At least you are close enough, Manoj. What my point is, please do not underestimate it. It is actually damaging a lot of structures.
No, that I agree. I fully agree with your comment.
All the fly-by-night operators are using pirated versions. They are not upgrading or buying genuine software.
I think Professor Yogendra Singh ji has raised his hand.
Alokji, the point is that it says only structural analysis shall be carried out. It doesn't talk of design, So analysis has not changed over the versions, actually. So it doesn't talk of design shall be carried out using standard framework.
नहीं, analysis भी change हुआ है ना boss. Load combination change हो गए, important factor change हो गए.
You see, in tall buildings or even in this kind of incremental construction where time-dependent analysis comes in, the analysis has to take into account several construction stage impacts. I mean, the code says 150 meter and above, but I think that was also challenged by Vipul. So when you take this stage by stage construction into an analysis, it is a very involved one. You need a software to do that. I mean, you can't do things manually. So, but in my view, the structural analysis shall be carried out using standard 3D computer model. That is good enough. I mean, if you add anything more, then you are also raising many questions rather than answering. Because if you say validated, there is a problem. If you say well established, there is a problem. So idea is to say that you are supposed to use a 3D model for computer analysis.
अरे भाई 3D model कौन सी सदी का होगा वो? There are still people using 90s and 2000 early 2000 versions of software which do not incorporate even the 2002 code. अब वो बैंक डिजाइन कर रहा है, आप रिव्यू कर रहे हो, आप उसका मॉडल चेक भी नहीं कर सकते अपने सिस्टम में, क्योंकि आपके सिस्टम में वो मॉडल चलेगा ही नहीं, खुलेगा ही नहीं.
Professor, I think your hand is raised. So
actually, this is a tricky issue. The software, people can write their own software also. So we have to think that whether we are allowing that or not. And if I have written my own software, how it will be validated?
I don't think we are allowing that. We don't expect you to write your own software to do a 150 meter tall building.
Well, we can think about it because OpenSys, which is very popular and very well respected compared to proprietary softwares, is considered to be a very reliable software written by individuals and contributed. So I tend to agree what Mr. Bhomik was suggesting, that we should remove all this. We should only say, because software is a tool. Whether you are using, like in design, whether you are using your own worksheets or you are using a software, it is the designer's responsibility to ensure that the latest codes are followed, whatever tools he or she is using. So all that should be left to the designer, how he or she is doing. Code should not specify the software. Code can only specify that it is necessary for this type of complex analysis, that a computer program is used. So that can be perhaps the only thing we can specify, we can think here.
I do not agree with you, sir, with due respect.
Benchmarking of the software.
No, I do not agree with you, sir, because a review, peer review, how is it going to happen? Unless my system does not understand your software, how am I going to review it?
Okay, so because
for any important building, ultimately, standard, well-established software is required so that be it a CPWD, railways, DMRC, or any client's project, they are able to review my design, my analysis, my design, they can understand and they can actually run it and check it. So there is no harm in using the term well-established structural analysis software, preferably the latest versions available in market. Why? So that they are compatible with the latest revision of the earthquake codes. I feel, look, it should be recorded and conveyed to the committee. You may or may not agree with it, but please.
I fully agree with you, but that problem is not solved even with writing well established, because there are so many proprietary software. Somebody is using Sophistic, I am using SAP. So it is possible only if we agree in the beginning. The reviewer, like we were talking about the interaction between architect and structural engineer, even more important is the discussion between the reviewer and the designer. So they should be on the same page from the beginning. They should be using the same software.
Sir,
so,
unfortunately,
I have a question. I have a question here.
Unfortunately, ऐसा होता नहीं है. Consulting engineer.
Architect से तो बाद में expect करेंगे. पहले structural engineer.
Just a minute.
So
just a minute.
Alok, let me answer what he just said. In consulting fraternity, more or less, give and take a few exceptions, ETABS and StatPro are the only two softwares being used in the entire consulting fraternity. And believe me, I've been working for 40 years, so I do know a lot of what is going on. And I think it is important to mention that, yes, it's okay that the structural engineer and the reviewer should have a discussion. They should understand each other's software.
Sangeeta, can I come in here? I have a question to this esteemed panel. Suppose there is a building designed using a very well-known, popular, validated, latest version software, and it turns out after the execution that there was a bug in the software, and because of which the building later on proves to be unsafe. Who is responsible for this? I mean, let me ask this question to this panel.
Yeah, तुम structural engineer जैसी बात करो ना. Don't talk too.
No, I'm asking this very serious question. I mean,
no, I don't think
will be responsible, Alok.
This is too hypothetical a question.
See, there are disclaimers by all software manufacturers.
So therefore, it does not matter whether using a validated software or an unvalidated software.
I don't think that is a good
what matters
statement to make.
is the output that you give. You are owning the responsibility for the output that you are giving.
Alok, you cannot get the right output if you don't get the right software on board or right engineer on board. Both the things are equally important. The structural engineer's knowledge, his final touch is as important as using the right software. They are both critically important. I don't understand why it is being downplayed. क्या problem है हमको latest software use करने में?
Because in many of the, even if it is the latest software, the way the pace with which our codes are getting changed, even the latest software, I am telling you, do not take into account the important changes which are made. Maybe a small incremental.
Don't make such statements. These are not correct statements.
Let us be serious.
There are bugs in every thing, and one has.
So ultimately, basically, as a structural engineer,
anyway,
when you are designing, you have to take the
let us take it offline, please. Let us take it offline. Let's not discuss it.
Can I say something?
Yeah.
ऐसा है कि we have panelists ने बहुत सारे questions raise किए हैं कि basically this clause needs revision, right? This is important.
Okay.
But please do convey
move
my
forward, sir.
reservation. Please do convey my reservation and clear-cut comment that latest revision of the code and latest version of the software needs to be followed to be able to arrive at code compliant design.
Yes.
Otherwise ये नहीं हो सकता.
Yeah.
100 मंजिल की बिल्डिंग या 50 मंजिल की बिल्डिंग आप मैनुअली चेक नहीं कर सकते कि आपका आउटपुट सही आया है या नहीं आया है.
Okay, let's
That
move forward.
validation-
I think let's move forward. We have long.
Yes.
We are
Yes,
already
let's
at
take it offline,
5:40.
please.
So, Abhay Ghateji, you have raised your hand. If you want to say something.
I entirely agree with Sangeeta on this point, because the Dubai municipality has got a clause which says you have to use only the latest software. You
Yes.
cannot use it has got a clause. They will not accept it in any other version other than the latest available code.
It is very important. I don't understand why you are not able to understand it.
I agree with Sangeeta on the Singapore government also has got a same identical clause that they will not accept calculation based on any other version which is not the latest version. So Sangeeta
Right.
has got a very valid point.
Alok, we
No,
are
my,
getting- Alok,
I
we
think.
are getting- Alok, we are getting a lot of comment that we should move forward.
Okay, so let's move forward. I think we have covered up to clause number 7. Any other point on clause number 7? I think let's move to clause number 8, which is structural design.
No, I have a comment here.
Yeah.
Floor diaphragm flexibility. I
Which
feel
clause?
that
Which clause? Which clause? You are
it is 7.2b.
Okay.
I feel that there is a lot of confusion and lack of familiarity with the exact method to determine whether your floor is flexible or it is rigid or it is semi-rigid. So I feel some kind of guideline should be added here for the structural designer to understand the floor diaphragm better, whether it is going to act like a rigid diaphragm or not. Lots of our designers are not familiar with this intricacy of this clause, and this important criteria is being overlooked in the design. So that is
1893 already has some guidance on that.
Some guidance, but Vipul उसको थोड़ा और explain कर सकते हैं. यहाँ पर इस particular code में भी डाल देंगे तो कोई नुकसान नहीं है.
So maybe this can cross-refer to
I think
1893.
Or a reference can be added to 1893 part 1.
Yeah, I think I request all the panelists, whatever points they are making, if they can give it to me later on after this webinar, so that I can compile and then put it to the BIS in
Sure.
all the clauses which they are referring to. It would definitely help me to compile.
Yeah.
So let's move forward.
Yes.
Now in this table 5, hold on, please. In this table 5, I think
One minute, I was not done with 7.2D. Let's go back to that D.
Okay.
Okay.
Yeah, that equation over here, it says this load combination is for the initial analysis. Okay. And this is only when you're doing a static analysis. But if you're doing a dynamic analysis, then you only apply the gravity load first. Correct me if I'm wrong, Professor Yogendra Singh. Otherwise, in a dynamic analysis, all the signs are lost.
Sorry, I could not hear, Mr. Aljo. Can you come again?
Yeah, on this 7.2D equation, this is only for the initial analysis, considering P delta effect, and that too when you are doing a static analysis. Because in a dynamic analysis, all the signs would be lost.
Signs will be lost. You mean earthquake EL
Yeah.
sign will be lost?
Yes.
Yeah, so
So therefore, this initial analysis, either you'll have to push the building statically one way and then restart the analysis and do the dynamic analysis. That will only be valid in that direction, that sign.
but P delta will be when all the signs, all the displacement will be in one direction, P delta
Yes.
will be done in that direction. That will
Right.
cause additional forces, and those will be added with both the signs. Will not that take care of it?
Yeah, see, the thing is, if this is done, let's say for one direction in plus or minus, then that's the only direction that dynamic analysis will be valid. It will not be valid for the other directions.
Now, if I take a minus sign to all displacements, that will be valid in the other direction.
No, because the building is asymmetric totally.
What you are saying, that effect will come in case of nonlinear analysis. But as far as linear analysis is concerned, we multiply by minus, because principle of superposition is valid. So if we multiply it by -1, that is a valid solution for opposite direction.
No, with the combination over there, the behavior is going to be, the tension is not going to be equal to the compression when combined with the dead and live.
I think I'm not able to understand. We will discuss later.
Yeah, okay.
Perhaps to me, it appears to be okay, whether we are doing static analysis or dynamic analysis, as long as we are doing linear analysis.
Vipul, I think if you can put it in.
Nonlinear analysis.
Yeah, we'll talk about that.
Yeah, if you can put it to me after discussion with Professor later, that would be great. So we move to table number 5, next page. And I was just thinking, somehow this, coupling beam is missing here, no? Or do we not need to keep another table for the coupling beam?
Yeah, actually, I showed a whole that ASC table in my presentation also. So that, if you look at that, it shows that ASC table.
I think we should also add coupling beam here.
Yeah, coupling definitely, and
because that will have a different moment
also
of inertia.
The shear crack section.
Also the shear, which you added. Yeah. So this requires a modification, this table.
And also raft, maybe.
Raft is missing. Yeah.
Yeah. Now come to clause 7.4.1. Sangeeta.
Does anyone have any comment in between?
Yeah. Okay, this one. Now here, I think this last...
wait, 7310, that theta, that comment that Professor Singh was saying that R value is misplaced.
Yeah, that we have already discussed. If there is anything more...
But CD is all, but I mean, if you look at ASE, that CD parameter is there in place of R.
Yeah, actually, because this difference is arising because the delta I, which is in our code, which is written here as the design story drift at level I. This is a different entity, and the delta given there is a different entity. So their delta is multiplied by CD. So that's why they are dividing it by CD to come to the same level as we have in our case. And in our case, delta I is already the reduced value. So at the reduced load, so it is already divided by R. So there is no need to divide by another R here. Otherwise, we can also see with the limit. In zone 5, the limit, if we multiply by R, it will be 0.048 into 5, so more than 3%, which is in any case unacceptable.
Okay, so let's move forward. I think we go to 7.4.1. Yeah, so if you see the last line, that is little disturbing to me. It says measures shall be taken in concrete and composite buildings to minimize the adverse effects of shrinkage and creep, temperature variation and foundation settlement during the design life of building, which is not less than 30 years. So in my view, 30 years is too little in today's scenario. When we are talking about sustainability, when we are having a tall building, why are we thinking in terms of 30 years? It should be at least 100 years in my view. I mean, on what basis are we, which return period we are taking on the basis of 30 years?
See,
any comment from the panel?
Yeah, 50 years is for
even the normal standard building.
So we talk about probability of this 10% exceedance in 50 years. So that is the general yardstick. Even the wind loads are for 50 years.
Yeah, but in today's scenario, when we are talking about sustainability in such a big way, we should think of extending the design life rather than reducing it.
All
But
these are
practically ऐसा
probabilities.
हो नहीं रहा है ना आलोक.
All these are
बिल्डिंग्स में
probabilities.
ऐसा हो नहीं रहा है. 5 साल के अंदर बिल्डिंग्स डैमेज हो जाती हैं, कोरोजन
वो
हो
अलग
जाता
चीज है,
है.
वो अलग चीज है, वो
नहीं, आई एम टॉकिंग
अलग
अबाउट
चीज है।
रियलिटी. आप थ्योरी की बात कर रहे हैं, मैं प्रैक्टिकल की बात कर रही हूँ.
Professor Singh, I
Hello,
think
Yeah,
question
Professor Singh,
answer.
आप कुछ बोलो.
Yeah, I think here the purpose is different because the shrinkage and creep effect depends on the age. So perhaps what they indicate is that it should not be less than 30 years. So that if we consider for 30 years, then we don't expect much change in the remaining life of the structure. That's perhaps the intention.
Yeah, Mr. Hegde also said the same comment, same answer in the question answer box.
What is that?
I think you can see, keep on seeing that also, because the people are responding there also.
Yeah.
ये सुनो.
No, but you see, whatever may be the intent, but this statement gives a indication. One can argue that design life 30 years is what is the intent of this code. So maybe a framing of the sentence
Agreed.
can be improved if the intent is something else.
No, but I
No,
think
they
that
are
the
not-
design
they are
life
not
should be
saying-
mentioned.
They're not
Design
saying that
life
a
should be
certain-
mentioned right in the beginning.
Beginning
As
itself.
In the scope, it should be mentioned as to what should be
Yeah.
the design life of the structure.
Yeah.
ठीक है, okay, English can be improved, okay.
And certainly not 30 years.
So 30 years may be okay for this shrinkage and creep for this thing. Maybe
because it stabilizes in 30 years.
yeah, so that may
No,
be
so-
that may be correct.
So
but-
therefore, if it is instead of 30, even if you take 50, you are not going to increase the stresses because it stabilizes. Then what is the idea of this 30 years if it is going to stabilize after 30 years? You see, yeah, it's a shrinkage and creep and all are materialistic phenomenon. So by writing 30 years, what are we arriving at? If it is a design assumption you are talking about, you can mention that, for the purpose of estimation of creep and shrinkage, you can take a life of 30 years. That is completely different from taking a design life of 30 years. Design life has a different meaning, I say.
Yeah, the language is bad, but that's all.
The language is not correct. Otherwise,
Okay.
intent and other things looks to be okay.
Okay, so let's
Language
move.
needs modification.
Sir, let's move to clause number 8. If there is any comment on structural design. So if there is no comment, we move forward.
Yes.
I request all the panelists also to see at the Q&A box as Manoj was mentioning, because you see, there may be many comments there. If somebody
So
wants
there
to
are
pick
already
up.
many comments. There are 60 comments there. So
Yeah, but
I think, Manoj, it may not be humanly possible to answer all those
What-
questions now.
maybe what we can
After
do.
They can be sent to us.
you can take
In,
some of them. You can take some of them. after.
no,
I've
the
already answered
questions.
some.
Yeah, first let us complete all the clauses and then we'll come back.
No,
So,
I suggest, Alok, please listen to me. The questions should be circulated to the panelists, and those of the questions that we would like to answer, we'll
Yeah.
answer and we'll share with Vikas, and that compiled thing can be emailed to all the participants.
Even
Okay,
some of them
we'll do
are
that.
answers. Alok, even some of them are answers to
ठीक
the
है.
questions you posed.
Yeah, so Manoj, why don't you do that? If you pick up certain questions, please feel
Yeah.
free to pick up questions and we can put it in the panel.
Okay. चलो तो आप continue करो. I will do that.
Ah, exactly. Thank you. So now coming to clause number 8, if there is no view from the panel, then we can move forward, or
I
you
think,
think?
I had covered like the staircase over here, 8.1.2.
Mhm.
So those points have already been covered.
Yeah.
It's not that.
Yeah. Yeah. Okay. So we move to the next one, which is foundation, where
This
I
is
think,
this 8.1. If you stop over 8.1.3, 3.2.1 sensitive analysis. So there's an exception over here as part of a collapse prevention evaluation. Is a tall building is evaluated for collapse prevention. I think this admission is a first one that we are seeing, that the code somewhere mentions that it is being designed for collapse prevention.
The intent, thanks for pointing it out. Yeah. So we go to the foundation then, clause number 9.
I have one point regarding this design.
Yes.
Actually, our code IS 13920 plus 16700 put together, these are lacking on part of design of shear walls. Many things are missing which needs to be added, which we can point out. So one thing is that they are reducing the thickness to 160 from earlier one. It's not a good start, as Mr. Ahuja has also pointed out. So that is one thing. We should say that minimum thickness should not be reduced. Secondly, our codes do not provide guidelines for capacity design of shear walls, which is another important aspect, which has been included now in both ASCE as well as, ACI 318 as well as Eurocode. So our code should also include guidelines for capacity design of shear walls. Then design and detailing of different types of coupling beams. We have only one type of coupling beam at the moment, that is this diagonal reinforcement. So in different conditions, how different type of coupling beams are to be designed, that should be either dealt with in IS 13920 or in 16700.
Especially steel plate reinforced, because that, the shear is very often exceeded, and then people start falling back on research and all that. So,
okay. Okay. Any other point? Otherwise, we can go to the next clause.
Which one?
I think if you look at 8.1.331, which is the backstay effect.
And same thing is applicable to these flat slabs. We are having a ostrich approach. We presume that flat slabs are not being constructed, or if those are being constructed, those are constructed as per our code. That's not the situation. So our code currently gives very little about design of flat slabs, and that needs to be extended.
Yeah.
Lot of guidelines are now available on design of flat slabs. So those need to be included.
Yeah. Okay. Thank you.
Yeah. I think there needs to be, there's a very big and important section. There needs to be some explanatory features. For example, if you go to subsection F, like father, and if you go to 5, so it says adequate measures shall be taken to prevent shear sliding failure at the connections of diaphragms to structural walls. Here the inclination of strut shall be 45 degrees. Now, I think a picture is very important in this case, because people who don't realize what this is going to be will have, their imagination will be running wild as to what the code is trying to convey. And additional reinforcement shall be provided to resist shear force at the interface between the diaphragm and the structural walls. This, and nobody I have seen ever does, any of this. And this front must be explained with a sketch.
Yeah. Okay. So can we move forward? I think all these comments I would request.
81333, this the one that you're on. In the next page, item C2.
Next page.
Yeah. C2, the equivalent static seismic forces can be used, provided they are scaled to match the base overturning moments obtained from the response spectrum analysis. Here again, a figure is it should be provided, and we are saying that from the respective tower it should be, okay, in the direct load path model. So this should be made clear.
Okay. Okay, can we move forward?
Where do you want to be?
9. Foundation, yeah.
Okay.
If there is no other comment, I have one comment here. If you see 9.2, I think this, though it is not a change, it is there in the existing code itself. But I find, it is, I think, not true, not correct. The language. It says a factor of safety of 1.5 shall be provided against overturning and sliding under A, unfactored design wind gravity loads, and B, 2.5 times design earthquake load and unfactored gravity loads. It gives a impression that 1.5 factor over and above when we are taking 2.5 times the earthquake load and unfactored gravity load, you are supposed to have a factor of safety of 1.5. I don't think that is the intent. I mean, no structure can give you that kind of factor of safety. So it is, I think that's 1.5 factor is with A and not with B.
Yes, I think so.
That language needs to be changed, I think.
I think you can just ask them to review it, because I don't see anyone here in our panel from the 16700 committee. Is that right? Or Manoj, are you a member?
No.
So let us not presume anything on the intent. Let's just pass on our comment and ask them to review it.
Just ask them to review it.
Yeah. Next, you go to 9.3. There, I think there is the way it is written. I mean, geotechnical 9.3.1 and all. It is like whatever is given in other geotechnical investigation code. You can simply follow that and give a report. But when I think being a tall building where foundations carry very large load, very large, very high level of magnitude of lateral load, vertical load, etc. I think there is need for giving little more importance on the geotechnical investigation in terms of the level of reliability. That somehow is missing in the clause, Also, if you see the depth of borehole, that's also very vague. I think Mr. Girish pointed it out. Depth of 1.5 times estimated width, smaller plant dimension of tower footprint subject to a minimum of 20. Actually, that is not correct entirely. If you see the code 1892, which is on geotechnical, investigation and the depth of borehole, it depends on the footprint of the tower. If you have, let's say, two towers very close to each other, then this is not the minimum width, it is the maximum width into 1.5. All that is very clearly specified in 1892. But this seems to be undermining the 1892. So I think this clause definitely requires a lot of input from the geotechnical specialist. Very correctly. We can only point out the comments, but I think it requires input from geotechnical. It should not be less than what is already specified in 1892 for normal building. So these are my observations. Regarding the clause 9.8.1, if you go below, scroll down below, Sangeeta, come to 9.8.1. Yeah, it is now here also. If you see this criteria given, settlement may be relaxed to 125 millimeter, the maximum vertical settlement may be relaxed if you really see IS 1904, which gives the permissible settlement, nowhere there is any allowable settlement more than 125. So where is the question of relaxation? Rather, I think this clause needs a review with respect to the even the stated code 1904 and 12070, and it should be more clear. Okay, so any view from the panel?
That the bearing pressures below the raft, when there are maximums which exceed the allowables, okay, then what kind of averaging, what way the averaging should be done should also be spelled out, because we don't go with the peaks, but a lot of engineers, in the reviewing panel, usually they insist on going with the peak, and therefore that should be clarified in the code.
Okay. Okay, so clause number 10 is non-structural element. Any view?
Yeah, in my talk I had expressed all that, and I think Mr. Dravid had also agreed with that.
Okay. So we go to clause number 11. Clause number 11 is on, I think, instrumentation.
Monitoring, yeah.
Recommendation for monitoring information and all.
Yes, yes.
So, any?
So I think if it is
I only have one comment.
correctly.
Yeah, I only
It's
have one comment here.
implemented. Yeah, sorry. Go ahead.
Sangeeta, I have only one comment here. We are only here, nowhere, no one is talking about the instrumentation of the or monitoring of the foundation settlement or foundation behavior for tall buildings.
Nahi hai
I
na
think that
isme.
is
Hai 11.3.1.
okay.
Foundation
Okay.
settlement
And
is there, but there is
11.3.2.
one issue that they have written that triaxial accelerometer will be placed, but at which level, how many? That question is not answered. So
also, why triaxial? Why not biaxial or uniaxial? I mean,
triaxial because it will give in the three directions, but it is not going to give us the rotational, torsional behavior. So
it has to be a combination. It has to be a combination.
So I mean that
triaxial word to be used kiya nahi hai.
that also needs to be specified that what will be the location where those will be located. So generally it is at the top and bottom. I mean at the base it is triaxial. Then at the top there are uniaxial or biaxial in two directions. So that we get, and at the two ends of the flow, so that we get the torsional behavior also.
So I think little more elaboration of this codal clause is needed, so that the designer does not use it as a black box, use triaxial and wherever you use doesn't matter. It is not like that. You have to have a proper instrumentation plan to understand as to what all you are going to measure.
Exactly.
Okay, so we come to
I have a question here that who is going to monitor settlements and who is going to monitor deflections? Who the design engineer or who is going to monitor?
No, it is for the owner to decide as to how it is going to be done.
Yeah, but somebody has to monitor and interpret the results. Only the design engineers can do that.
Yes, yes.
Not
it's a very valid point. ये बड़ा मुश्किल है इसको थोड़ा. I think इतना सोचा नहीं गया होगा कमेटी में इसको discuss.
I think.
Abhay Girish here.
Yeah.
So we have been doing instrumentation in Mumbai on about 5 to 6 buildings in last 3-4 years, and on one of the buildings you were also involved, the Reja's building. So what is happening is these sensors are now programmed to give you alarms on multiple handheld devices like your mobile phones. So whoever is authorized to know the performance of this outcome of these sensors, output of these sensors, they get readings at a period, a pre-decided period, let's say once in a week or something like that. You get this data on your mobile. So structural engineer is invariably one of the participants in this program. but the person from the client, someone from the contractor, they are also added to this group. So there is nothing like who will do it. The design as well as the construction team and they have to decide who should know this output. And it's all accelerometers, all settlement sensors, all tilt meters, they are connected to your mobile.
The point what I'm making, that the engineer's contract should be valid for that length of time.
We are doing that. No, we are doing that. We are doing that, Abhay. So in our contract, we have a clause saying for next 3 years, we will monitor and submit a report, periodic report once in a quarter to the client saying everything is all right or something needs to be done. So that has been happening.
And I think
the greater question is here, code, along with the code, there should be an act, somebody responsible, there should be an act by which the clients should be made responsible to appoint somebody to get it done, something like that.
That's not there. Yeah, you are right. That's not there. But I think because we are following, structural engineers are following this code, we should do it. So we have been telling client that there is a provision in this code. Shall we do it? So clients agree to us.
Yeah, basically this code, I think they are just mentioning that this should be done. They are not going how it will be implemented. That depends upon the authority or the owner or the user or the consultant. I think they are not going to that kind of a detail. They're just mentioning that it should be done, and that's all.
Normally, if you are going to instrument a building or any structure, normally there should be a maintenance manual generated by the design consultant highlighting exactly, in great detail as to how the instrumentation, what are the results and expected and in what period or frequency they are to be reported to the client and for what period. So it should be all part of a kind of maintenance manual, and that should be a responsibility of the design consultant.
That's right. That's right. So when we make our structural BOQ, our items are very few. It's concrete, formwork, and reinforcement, at the most structural steel somewhere. But we have started adding this item in the scope of contractor himself to put all these sensors, including pressure gauges below the raft and all that. And it is his responsibility to contract with the sensor manufacturers like Trimble and all those people. And he makes this arrangement to prepare a group, make a group and transmit all the data to relevant people. So it automatically happens if it is in a contract. So I think it is our responsibility to implement this.
So how do we, what is according to you to be added in the code to make it clear?
I think we should send a command that this portion needs to be elaborated, detailing the maintenance, because there is nothing about maintenance, utilization of the results, and reporting of the results. So whenever the response exceeds a threshold, this response has to be reported to some authority so that that can be used in further development of guidelines. That is also the purpose. Their purpose is not only to do the health monitoring of the building, but also to get the results, a database of the result, which can be used for further development of the guidelines.
Correct.
So there should be a repository with the agency, like in Bombay, we are having the municipality who has issued that notice. The same agency should have a repository. So all those details need to be clarified in the code.
Okay, so we move forward, sir. I think we come to Annex A then. Annex A is a very controversial annex, and I'm sure the panelists have something to say.
A lot of things to say, I think, on this.
So, Professor, you can start.
Okay, so the major issue here is that I was listening to the recording. I could not attend the live program which was done by the code committee, but I was listening to the recording of that program. And it appears that the confusion is there itself. It is not very clear that what to do with code exceeding buildings. One document which one of our panelists was showing from Bombay, there also it is mentioned that performance-based design will be done. But the question is using which guideline, which code, which criteria, that is not clear. This document also, at many places, it refers to nonlinear analysis. Somewhere it has written performance-based design also. It talks about selection of time histories, which are required for nonlinear analysis only. Then they are also talking about nonlinear model to be collected from the designer. So there is confusion, and then it is not clear that how those widgets will be utilized. If, even if a panel is formed by the competent authority, how that panel is going to take the decision on this type of building? There is no other way except going for nonlinear analysis and performance-based design. That is not coming out clearly here, and that has to come out clearly. Although the committee chairman had other view, let's not go into that. But from our side, at least we can send whatever we feel.
Yeah, thank you. So, Professor Tandon?
Yeah, I think that this is an unprecedented step that this code has taken. There is no other BIS code, to the best of my knowledge, which has a provision like code exceeding whatever it is dealing with. I mean, why is it necessary to do that? What Professor Yogendra Singh just said, if we just allow people to do that, why do you have to make a panel out of this thing and all that? Then people will start doing all kinds of things. As a matter of fact, there is so much of confusion. There are contradictions between 1893 and 16700. And it says that you can use this for buildings smaller than 50 meters. That itself is a confusion. So where is the question of going into this another panel and all that? I don't agree with this. I mean, it is up to the municipality owner, whatever, to get an expert to do the design check, as we would do if it is a bridge which has got an sort of unprecedented, there is no code available and all that, and yet you want to make it. They will find a specialist whose knowledge is more than the designers, and get it checked. I don't know why this thing is there, and why don't we have it in every code?
Yeah.
Not
Any
only
other
that,
other view?
Yeah, not only that, the SDR panel, who checks the competence of them? I mean, what's the somebody may have done 10 bad wrong buildings, that much height. What is there? Who is there to check that?
I think this is a ill-conceived idea. It will be difficult to implement, and if implemented, there will be a lot of question mark on that also. So I think this needs to be reviewed thoroughly, and I think ISTT should write to the BIS.
I think who's going to take the blame in case something really goes wrong after all this?
Committee, then this panel will be responsible. Otherwise,
is the panel going to be responsible?
No. It is very clearly mentioned here that the correctness of design, responsibility of that lies with the main structural engineer.
Right.
And the reviewer or the SDR panel will be only trying to safeguard the client's interest.
So they are just becoming the super boss. They are just trying to be the super boss. So that's all.
I think there is a super boss required in India. बिना डंडे के हमारे यहाँ कोई काम होता ही नहीं है.
So then there should be a mechanism to appoint them.
No, I think this is an
escape. They have taken a step in the right direction. Only thing is, it needs to be fine-tuned.
Yeah, there should
as time progresses, they will realize that there are not enough experts who've actually done more than 10, 150 meter, more than 150 meter buildings. And maybe the relaxation in the qualification will come. But the review panel, I think, is a good idea. I don't agree with the concept that it's ill-conceived idea. I don't think that's correct.
Any idea which is difficult to implement or not cannot be implemented. That is it.
भाई इम्प्लीमेंट करना है अगर मुंबई में हो सकता है तो दिल्ली में भी हो सकता है.
Yeah, they need to discuss this idea, and they should come out with a practical idea which can be implemented.
Okay.
See, Mumbai has done it, so Delhi can also do it, no?
Well, may I say something?
There is a live example. Girish ji has already shared the documents where he is also one of the panelists. So where is the problem then? If Mumbai can do it, they are sitting in zone 3, we are sitting in zone 4. Why shouldn't we do it?
I mean, I have a basic question. Who's going to fix their fee?
सर मैं आपको एक बात बता दूं कि जो ब्रिजेस में क्वालिटी ऑफ डिजाइन हो रहा है, मैं उसके बारे में कोई कमेंट नहीं कर सकती, मुझे बिल्कुल आइडिया नहीं है. मगर बिल्डिंग्स में जनरली जो क्वालिटी ऑफ डिजाइन हो रहा है वो बहुत ही ज्यादा पुअर है. एंड इट रियली स्केयर्स मी टू डेथ टू थिंक ऑफ व्हाट कैन हैपन possibly to these buildings. So I somehow feel that the list that is given in Annexure A is pretty exhaustive. It is probably a bit too late. पहले ही आ जानी चाहिए थी ताकि आप आर्किटेक्ट को दिखा सको कि भाई ये इरेगुलरिटी अगर लगा रहे हो आप तो ये एक्सेप्टेबल नहीं है 16700 के हिसाब से. अब आपको ये एसडीआर पैनल में जाएगा आपका प्रोजेक्ट और हो सकता है कि वो बहुत रिगरस डिमांड है उसकी डिजाइन सबमिशन की, तो दैट मे एक्ट एज अ डेटरेंट टू an architect or a client in coming up with something very fanciful and not
right. Sangeeta, you're right. That is what happens.
Yeah.
Secondly, I want to answer Professor Tandon's question. Who decides the fee? So I decide the fee. If someone comes to me to review his design, I decide the fee. People give because it is mandatory.
May I say something here?
Yeah.
So I think my take on this subject is following. That I think it's first of all, this idea of a non-conforming building to get passed through a whatever you call the SDR or ERP or whatever, that concept itself is fundamentally wrong in my view. You see, there is a difference between my perception of code exceeding building and a code non-conforming building. When you say code exceeding building, the perception is that, normally, whether it is a US code or Indian code, most of the code gives you a minimum requirements from the consideration of life safety. And when you say code exceeding building, means a client or the owner wants something which is over and above the minimum requirement of the code. So if you want a particular building which has a requirement which is more than the requirement of the code, then you call this as a code exceeding building. And such buildings where there is a performance requirement, whether it is somebody may want the structure to remain serviceable even after the major earthquake. So that is a requirement which is not a code, it's a code exceeding building. There you can have such provisions. But here what we are using is we are abusing the code by saying, if you read carefully table number 11, which Sangeeta very elaborated. What is table number 11? It's a good checklist of what is supposed to be there in this code. Whatever is you see, right from clause 1.1 to the end clause, whatever is in the tall building, that is there. It's a checklist. If you want to conform your design to IS 16700, you simply take the table 11 and make sure that you have conformed to everything. That is a compliant code. So that means by allowing this Annex A, you are saying that you can violate this code in any manner whatsoever. Instead of 250 meter, you can go to even 700 meter, use this prescriptive code. The only thing is you have to have an SDR panel who will decide whether what should be the method of analysis, and you have to comply with that. I think I think this is not the right way of going forward for tall buildings. The solution is, if you think that this code has a lot of limitations, then better to go for a performance-based design code separately. And you say that if you are not complying with this code, go to the performance-based design code.
See, Alok, whatever you have just said is very ideological or very theoretical. Practically, all this is happening. And I can give you umpteen number of examples of each category that has been mentioned in that table. And most of us are aware of those buildings. These are very popular common buildings in NCR region itself. I don't talk about Bangalore, Hyderabad, where earthquake code is completely not being followed, and they are not giving ductile detailing and still not doing any earthquake analysis. So let's not talk about those states at all. I still feel that these kind of buildings are now at least being brought under the purview of an expert panel, which will go through these buildings and give एक्सपर्ट एडवाइस. उसमें क्या गलत बात है? वो बिना एक्सपर्ट एडवाइस के भी लोग बनाई जा रहे हैं ना, उसको तो कोई देख नहीं रहा है, उसको कोई रोक भी नहीं रहा है.
No,
So
I
there
think
is no harm.
I have something to say on that.
Yeah, Tandon sahab, boliye.
The professional responsibility. Once you give an opinion, you cannot then escape that I'm not responsible. It is the guy who did the design is responsible. You are supposed to be the specialist. You are supposed to be the expert. So if you give a professional opinion, you have to be responsible for it. And in this code, the way it is written, they have got no responsibility except just give an opinion.
सर, तो रिव्यूअर का क्या काम होता है? आप नॉर्मली जो प्रोजेक्ट्स रिव्यू करते हैं उसमें आप अपनी एक्सपर्ट ओपिनियन देते हैं ना, पर रिस्पॉन्सिबिलिटी तो मेन डिजाइनर की रहती है हमेशा. इसमें क्या गलत बात है?
Connected with that project, Sangeeta, for your information, in bridges, in NHAI, if there is a problem, everybody connected with that project is first blacklisted. You have to then prove who's wrong and who's right. But the reviewer of the designer of the design, he doesn't go scot-free that he has just checked the design and given his opinion business.
Well, I think it is very clear. All of us do understand that the main consultant cannot shy away from the responsibility of the structural safety.
I'm saying neither can the reviewer.
सर, जो रिव्यूअर है वो तो रिव्यूअर है ना, वो कंसल्टेंट.
रिव्यूअर की रिस्पांसिबिलिटी तो होना चाहिए ना. रिव्यूअर रिव्यू कर रहा है, उसकी कोई रिस्पांसिबिलिटी नहीं है. ही इज सेइंग दिस इज रॉन्ग, दिस इज राइट, एंड देन अल्टीमेटली सेइंग आई एम नॉट रिस्पांसिबल.
No, I am not disagreeing with assigning some responsibility.
There is a parallel code in circulation which is on this designer proof consultant services. Yesterday only I read it. It has come. And there it has been specified that the proof checker as well as the PDC, principal design consultant, both will be responsible together.
Right.
So that is coming up. So
Great.
The architect,
we are deviating from our agenda.
Yeah.
Our agenda is to suggest changes or comments on the code. And what I feel that this code is failing on this account at the moment, that it doesn't suggest what this panel will do. This panel cannot summon the god and ask that whether this design is correct or not. They have to follow some procedure. That procedure is to be laid down. That
procedure has been very clearly laid down. If you go through the annexure in their depth, that procedure has been very, very clearly laid down. I don't see there is any ambiguity there.
No,
you can elaborate, my view, all understand.
No, you, Professor, I think, you see, I am of the view that this whole concept of Annex A and non-conforming building itself is fundamentally wrong. It is not, you see, if you follow this logic, then in any code, you can always say that if you are not following the code, then you have an annexure and you appoint a peer review consultant, and who will allow you non-conforming structures, whether it is IS.
We agree to that because
I think
is wrong.
Alok, we have already gone
complete.
to 6:30.
What I'm
We have to
saying-
close it.
Yeah,
We
yeah.
have to close it today.
What I'm saying is that if you think that this code has got so much of restriction that you cannot, the reason why this annexure is because the code makers have felt that the provisions in the code is such that you can never have a building which is absolutely conforming to this code, and therefore it is better to not to be in the denial and come out with a code which is performance based and say that if this code is not complied with, please follow the code number 2, which is on performance based. Finish.
आलोक, आपकी बात बिल्कुल भी सही नहीं है. Code makers have realized that exceptions are being made to the best practices and the codal clauses, and that is why this annexure has come. This table has come, this checklist has come only to educate structural engineers and the building community that these exceptions are not preferred, and if yes, they are there, then there is a set process, more complex process to be followed for review of the same. I don't think you are getting it right. We had a detailed.
So anyway, I think let's agree to disagree on many points.
Yeah.
But we are coming to close. I think you are right. We are already, exceeded by more than an hour. So
Yes.
we let's go to last annexure, annexure B.
Okay.
That is on I
Yeah.
think concrete. So if any comments on annexure B?
I think that it mention self-compacting concrete?
No, it doesn't. I think.
No, it doesn't.
No, then it should.
इसमें एक क्लॉज है जो कि पैनलिस्ट शायद घाटे साहब ने कवर नहीं किया, विच इज इम्पोर्टेंट कि वो आप स्लैब में जो कंक्रीट यूज कर रहे हैं और जो कॉलम्स में यूज कर रहे हैं उसमें कोई रेशो दिया है. आई डोंट रिमेम्बर व्हाट दैट रेशो इज.
70%. 70%.
70%. Yeah. So you can't just do this कि आपने कॉलम में तो बहुत हाई कंक्रीट आपने यूज कर लिया M70 और आपका फ्लोर अभी भी M25 पे है. That is not allowed. So अगर आप लोगों का कोई उस पे कमेंट है तो आप कर सकते हैं डिस्कस.
Actually, this clause is already existing in ACI code, and similar Indian code also had the similar clause for foundations. You know that. You cannot have a foundation of a different grade and a column of a different. And there also this thing was 70%. I think the clause is correct. You know that. I have no comments on that.
Okay, we should thank everybody and close now.
So only thing is when Tandon Sahab, when you say self-compacting concrete should be included, and if we use self-compacting concrete, then whether the shear wall thickness of 160 mm is on the lower side or is it okay?
No. Shear, the thicknesses and all that I am not talking about. I am talking about, for example, what Vipul showed as a slide.
Yeah.
And I have seen that in this aluminium formwork, because if you can make something which is very thin, and that is how it should be for in residential buildings. The partition walls, etc., should be only 100 millimeter thick. Why should it be there more than that? But to concrete that 100 millimeter thick concrete with reinforcement inside is not a joke. So it cannot be done by just increasing the slump or something like that. It has to be self-compacting concrete.
Right. So the reason why Vipul is saying that 160 is too less and 240 should be there is with the understanding that the concrete will not be self-compacting. Had it been self-compacting, he has no problem with 160 mm also.
No, that I think we have to discuss what is the minimum thickness.
I'm just raising a point.
Minimum thickness of a shear wall is another issue.
See, self-compacting is also got a cost element.
Yeah, that you leave aside the cost part.
Builders are not very, unless it's mentioned in the code that it shall be self-compacting concrete or something, nobody is going to comply with that.
Nobody is actually going to cite and check कि आपने बोला तो था वाकई में लगा भी रहे हो या नहीं लगा रहे.
I think we are talking about different walls. When we were talking about the minimum thickness of the wall, we were talking about structural walls. And what you are talking about is the non-structural walls. In my opinion, in non-structural walls, there should not be any reinforcement. Or if it is required for creep and shrinkage and tracking, it can be at the best wire reinforcement.
No, whichever reinforcement you put, because you see,
Yeah,
yes,
sir, I'm agreeing
with
the
that. partition wall has to have some strength.
Needed for thin walls.
But
Those thin walls
have
are
any
different than the structural walls. Minimum thickness 200 we were talking about. Those are different, not in context of these walls.
Yeah. No, totally agreed. I was not talking about the minimum shear wall thickness. I am talking about partition walls, which are being done now. If you are doing a aluminium formwork, the aluminium formwork comes along with your partition walls and everything. So in that, you can make something which is very thin, and people are doing that. We have provided about 100 and 125 millimeter, but I did not agree to just increase the slump. That is no solution.
Yes, actually, yes, self-compacting is the ideal solution, and we should follow that.
The more important point is the code does not address how the stiffness of the is accounted for. It talks about masonry, but does not talk about the concrete partition walls, and that's a major point.
Yeah, so I think we have had a very long webinar of I think we started at 3, it's now 6:35. So a long webinar and discussed, I think, all the clauses. So shall I conclude? Anybody wants to say anything? Or
I just want to say one thing.
Yeah.
That our participant might be having a lot of clarification that they can email to us. We can discuss with the panelists. But if whether they agree with the viewpoint of the panelist or do not agree, doesn't matter. They should write their feedback or their suggestions or their criticism or the problems in this code to the BIS directly. They can send it in the prescribed format within the time limit which is given by the BIS. So
that is 15th of September.
The committee CD38, because it is not necessary that this participant they should agree with our suggestions or discussion whatever has taken place. So they should send their comment directly to the committee, and our panelists can also send their comments to the BIS, and we will also from IS Structure side we will also send comments. But we cannot assimilate all, and we cannot send the comment of all the participants.
Yeah, Manoj, I think my suggestion is, because every individual has his own views, as you can see within the panel itself, there are disagreements also. So yes. Therefore, the correct procedure would be, in light of today's discussion, I would request all the panelists and the participants, they should go through the code and they give their comments directly to BIS. If they can also send a copy to us, we can compile. But eventually we will not discuss and give it as a IS Structure comment. It will be individual comments by the either the panelists or the participants. They can give it directly also. Even if they give it to us, we will send it to BIS as a comment by our member, as in person, by naming the person.
Alok, I would like to add something here. Alok, many participants are asking for the link where the feedback can be sent to BIS directly. So I'll request Vikas to share that link.
Sure, sure.
Format, the link and the format.
Thank you. So what we will do is, if you all permit, then to all the participants, I will also give the handouts of our presentations made today, and also the link of BIS where the comments can be sent.
Yeah,
but unfortunately today,
we can also send them the draft copy of the code.
Copy of the code also I will send. Unfortunately, Vikas is not here today, but tomorrow it can be done. No problem.
That is
okay.
So I think with that we can close today this session. I am very thankful to all the participants. Even after 3 hours, I see that there are 142 participants attending. We started with something like 300 something, 350 or something.
Alok, last one more point.
Yeah.
Just now, Dr. Yogendra Singh mentioned that there is some draft code they have received, and so I will suggest that that has already been circulated to so many our database. So I would suggest that they should also send the comments to the BIS on that code also. That is also very
वो
important.
आप हमसे शेयर कर लीजिएगा.
You are talking about that proof checking
I am
and the
talking about
consultancy.
proof checking.
Professor
and
Yogendra,
Yes.
Professor Yogendra Singh, I don't
that
have
code.
access to that
You
code.
should send the comment on
I
that.
can share with you, madam. I can.
If you don't mind, can you please share that?
Sure, sure.
Yes.
I will send
Yeah,
you.
that is a code where
Sangeeta,
think
we have
Manoj
shared
and-
that with you also.
Yeah,
Okay,
yeah.
I
it
can
is-
share
We
with
will
all.
do it again.
Actually, I keep getting at least 20, 30 codes every
Don't worry, we
month,
will
so I
send you
don't
again. We
keep
will
a
send you
track.
again. Don't worry.
Yeah,
We
yeah.
will send
Thank you.
Yeah.
Thank you.
Yeah. So I take this opportunity to thank all the panelists for really sparing their valuable time and having a very, very interesting interactive session. And I'm sure we all go back more educated on tall buildings than when we started 3 hours before. Thank you very much.
Thank you.
Thank you.
Thank you.
Thank you,
everyone.
everyone.
Thank you.
Thank you, Ji.